Hello, good afternoon. Actually, that is the wrong scene. I had the right scene all set up, and then I just didn't do anything about it. Hold on. I need to take off starting soon. Put me on. There we go. Hello. Hi, Albert. How are you doing today? We are going to attempt to complete this puzzle that we're on. Which is this infrared sensor. Now, we've been having a little bit of trouble with it, and I was thinking, okay, so I had a couple different thoughts. So I have two different plans for this. I think I'm gonna want to do a new design to play around with this. So the idea here is that we have our clocks, and it's supposed to be, okay, like, you know, if it's between these two times, right? Now this starts at the end, and that's great. Hi, Zilby, you wanna hang out? What are you looking for? Stacking, hello! How are you doing today? So I had one idea, which is I put one of these on each side of our times. So basically we have this coming out, well, I guess it would be out of here, and this doing the same thing to here. Actually, it would be this one. So basically on each side here. And then I do another one on this side, and we handle both cases. And then we send basically a one or a 0 out based upon whether or not each one is done, and then it becomes an or. If either one of those is one, then we just have the alarm on. So that's one thing that we can do. But the other thing is like maybe a math thing that I was thinking about. It's like, what happens if I subtract our on time from the off time? Now, if it's above it, that means that, or if it's a half, if it's over, if it's bigger, it's going to be negative. But I wonder if there's something we can do to just check, like, okay, above it if it's negative, below if it's positive. I'm not sure about that. There's some math things that I'm sure that I could do something about. This is the first idea I'd come up with, though, so this is what we're gonna try first. The left and the right. I wonder if I can like actually start over here. I think you need to be farther away. Ooh, if I need to use P1, that won't work, so you need to be maybe, oh, you need to be down here. Okay, in that case, you could just be right up close. And then if you're the opposite now, so you need to be slightly, you can't be right up close because these are the two X's, so you need to be like here. One more away. And then we have the actual time. So that's the actual, no, is this the, yeah, this is the actual time. Oh, nope, I didn't want to press escape. And then you're gonna go out into the P1. So you can go there. That feeling when building the chip is harder than the actual programming. I know. Oh, and then I also need this out here, so I can't just go directly in there. We're going to use U to split. So U, and then you go there, and then I have this P0 here that maybe I can use. Oh, except you're an X. Never mind. Okay, we'll do that. So now both these have access to the current time, both have access to the clock, and then we need their outputs. So this is where it's going to get a little bit tough, and I'm not exactly sure about this. Can I put a bridge over like this? No. Oh, okay. So this positioning might not work because I can't break out of this X. Yeah, okay, so I have to, everything has to shift over by at least one. Which kind of sucks. Let's remove our wires. So I'm right there, so let's go over by 2. This, I don't know if this needs to move. This might be okay. Also, the sensor is going to need to go in somewhere, isn't it? So this might have to be one more. Because the sensor needs to go into each of these as well, and these are P's. We have our, this is an X. Now, I suppose I could just put this down to here. I can't use this one anymore though if I do that. I could do a bridge though. Like that. And remove you. Now I can do the X. This X too. I haven't lost it. You go in here like that. And okay. So you have all the inputs you need. So next up, we only have vertical bridges. So I can't do something like this, although I can bridge up. That could be interesting. I need to go to the 2 X's. What if I bridge from here? Do something like that. Now for you, we go out like that. And I still have room to do more wires out this way. Okay, so now we have all the inputs necessary for these two to do their calculations, and then an output. Now I'm guessing / hoping that I could do something like this. Now, if I do like a P1 output here, that goes to there. I could do just an X to here or a P to there. Oh, they're technically traces? The bridge? See, I have no idea what I'm talking about with any of these things. So that's good to know. We're learning things. You need a P output. So let's say we need that there, which means you have to be something like this. Let's put another bridge. Wait a second. No, they're called bridges here. That's why I'm calling them that. I wonder, did they get them wrong? Oh, the green lines are traces. I thought they were wires. Or was wires called traces? Is that what they are? Interesting. Okay, so I now have output from this. I technically have room to do a big one. I wonder if I can get away with that. Hold on, let's try. If I put you there, we do that. You come in there like that. I don't even need a bridge for this trace. And then you go in like that. Okay, so this is just going to split the same time across any of them. So we want to move P0 to ACC. I want to move ACC to X1, move ACC to P1. I want to sleep 1. And then it's going to repeat that over and over and over again and send this on out. We can probably actually see this, right? It's trying to send that out, but nothing's reading it. Excellent. So then here, what are we going to check? Well, let's check you if in the case that the time is greater. So if we want to just make the assumption, I think we do. That way I save some coding space. So we just assume that the on time, okay, so let's do the case where on time is less than off time. So if we move X3 to ACC, oh, and we can actually just do math straight on this, right? As long as we don't sleep, we can do it multiple times too. So I might be able to do, I need to remember how to program with this. Oh, I didn't even notice this card to begin with. Okay, so, oh, we haven't played with registers at all. Okay, so we can test equal, test greater than, test less than. Right, and then there's a, then it's plus minus. Okay, then it's plus minus. So I want to test if, do I want to do something like if oh, we just want to, okay, we test this. So if this time is greater than on time, so test greater than, and it's going to be X1, X3. We're potentially true. So we move 1 to dat. And okay, we're in true mode, right? Otherwise, we're going to move 0 to dat. And then we continue on. And then if it's less than off time, so test less than X1, X2, move 1 to dat, so you're on. move 0 to that. I kind of want to do this as an AND, but I'm not really sure the best way to do that. We can look up maybe how to do an AND if statement in assembly. But okay, so if this, I guess that is an AND, isn't it? Because they both have to be plus, otherwise one of them sets it to 0. Oh no, this is an OR, like it's an OR, because if this one is less than that, oh no, but okay. In the other way around, it kind of sucks. So I wonder if I do need to check to see if you are test less than x3, x2. If you're less than x3 and x2, I want to jump to end. And end, we are simply going to sleep 1, and we're done. We're just moving. I could also move 0 to that, reset that, sleep 1, and then it goes back up to the top again. Okay. Is that, oh no, then I need to move out. So before I even sleep, I want to move that P1. So send that on out to this, and then we sleep. And then we're going to do this exact same thing here, except for the opposite. So I want to handle the case test. Wait, I did this backwards. I want to do test less than, test greater than. If you're greater than. So I want to do here is test less than. X1, X0. Jump to end. In end, we are going to move. That literally is the wrong logic. I want to do it the other way around. Otherwise, I always move 0 out. Okay, so we're going to move that to X3. Move 0 to dat. Sleep 1. Okay. Now, in this specific case, this on time is greater than this. So I want to check to see if this is greater than you. So test greater than P0 X1. Banzi, hello, how are you doing today? And if you are, then we're going to move 1 to that. Otherwise, move 0 to that. We're going to test less than P0 X0. Move 1 to that. Move 0 to that. And then we're in end mode. Okay, and then we want to we're going to get the inputs of both of these, and we're going to check to see if either of them are 1. And if either of them are 1, we send out, oh, the sensor. Oh no. The sensor, I can go in the middle here. This is why I wanted the horizontal bridge. Wait, did I screw myself over with this? Why did I put this sensor? I'm doing P0. No, I'm never doing P0. P0 is completely useless to me there. You feel like the Chinese government tricked you into learning. Who was it? It was Zachtronics was never involved in the Chinese government, right? Okay. Here's what we're gonna do. We're gonna do that there. That. Now I can come. They really need electrical engineers, so they made this game to trick us into liking it. Well, that could be true. Yeah. You can be sure? Okay. Well, I did my cabling wrong, and because of that, I can't break out, because now I can't do that. That's not gonna work. The Chinese government funds a lot of cool stuff. Interesting. I mean, that's cool. How do I break out of here? Okay, I break out of here by not doing this, and I go backwards. Oh, I'm not allowed to connect to self. Okay, that would have been fun if I could do that. Okay, so now we have room to come through here. Wait. Oh, those are X's. I need to go into... Oh, I need to go into a P? All right, we'll just spend money. Except you're a P. I mean, come on. What's a little short circuit? Oh no, this sucks. That's the only... Okay, so... Let's bridge here. Except you're P out. So this allows me to do that. So that I get the sensor data now. Sir, the project is complete, but unfortunately it's going to cost us $2,000 per chip to mass produce. I mean, look, they don't seem to care at all how much I cost. Also, these are really cheap. So far, it's 18 yuan. So this is not bad. This, however, is not great. I wonder if I need to make these smaller chips. So these have to be the same size because I'm using too much space. This needs to be a... This is an X chip, so that would kind of work. Okay, so that kind of works here. You go up there like that. You're not gonna like that because it's trying to connect to this pin. Okay. let's move you out here. And what do I have? I have a bunch of, okay, so, except I don't want to move, okay, I can't move through this chip anymore. I mean, is there any reason I can't just burn out that port? That's not gonna work. I can maybe move you back here. So that gives me a little bit more room. Does that buy me anything? Everything was fine up until I realized that my wiring system didn't work. That was not great. So I need to get the sensor into there like that. Which kind of sucks because I only have, okay, so what if I put this there? No, I still can't go through here because I can't jump out. I don't think I can do this. I can't like bridge in the chip? Okay, fine. It's such a good idea, except I don't know how to make it work with the wires. But I feel like we're a lot closer now than we were at the end of the last stream. So I feel like I have to reset a little bit with the wiring system. So hold on, let's try this again. I'll keep the code in there because the logic at least works. I like move these off the board. That'd be nice. Okay, so I can't go all the way to the left because then I can't get wires over here. Somebody said that they put this stuff over here, which could potentially work. And I have room for, I could do something like this. Flip you around. Go like that. I can't put any cables there, but I could do a cable there. And go down like this. Jump over you, and then we've got that. And then okay, so I can't do that though because so you need to be one farther away. Then I can escape out like that, or escape out like that. I think I need to be out here for room to get, is that true? Let's see, you are an X, so I can put you there. The sensor we don't care about at all. This could go through, it needs to go through the middle all the way to this thing at the very end, which may not need to be a big one. Maybe we can get this to be a small one. And if I could put a jump like this, I can go out that way to the end. And then this P goes down like that. Then we have these two with the time clock. So what if I move you like this? Now this one needs to jump out and escape somehow. Actually, you're going to here. And now you're moving this out to here. You're only a P, so we're kind of screwed here. Unless I transform the sensor to an X or transform this. So you can put a P here. I can't do that unless I move you out a little bit. Okay. Oh, what did I do here? Oh, I can't do that. But I can move this further over. That works. So all I'm doing here is I'm converting move P0 to X0 sleep 1. And then for you, I need access to these things here, which means potentially out like this. Okay, so you need to be one further out, but I can't do that. I'm out of room. So I can't use this P0. So I can't use this P0. This P0 is for the time coming in. So this one is move T1 to ACC. Yeah, because now we're screwed in that this is so far away. I now have to move the time elsewhere. I think we're in the same exact spot, but we just moved the problem to somewhere else. And the problem always comes back down to wiring or tracing. It's like, okay, hey, if we can have like a little bit bigger baseboard, I can make it cheaper. I can use less components on it. This to convert over is not great. Now maybe I don't need this at all. If instead of you, I'm using a big one here. So either I'm going to lose the X3 or the X2. Which is fine. We'll just have to be aware of that. Because I can't put something there like that. Alright, so if I do this. This X1 coming out. Okay, no, X1 is coming in. Okay, so you're getting input, input, input. The P1 is what's moving out. And so if I try to be a little bit tighter with this. I actually do have room for a converter here. I could put a small converter. And do something like that. I need the sensor. This sensor. Okay, so to move through. If I can move like this. To put a bridge over like you. Okay, that makes you happy. And now I get the sensor all the way to here. And I now need to connect you to this thing. So this is P0 right now. No, wait. Oh, P0 is the time. So I need the time to come out here. Wait, so you're connecting time to here and time to here. That's completely useless. Oh, that's fun. Now, I could do this. Can I move you? No. Sort of. Okay, that gets my sensor over here, and then I get time to here, but that's not helping at all. I need to go. I need to get this wire through here, so at some point in time, oh man, this sucks. Do I want to do another converter over here? Like, can I put a converter here? Yes, please. Is it advice or like, either way, I'm fine with it. Yes. We're pairing together, right? Even if you all know what you're doing and I don't. But that's how learning happens, right? I'm the driver. You're way overthinking this. This can be done with 2 components. I tried two components in the beginning and I ran out of code space. So if we go back, was this the one I tried? Yeah, this is the one I tried with just 2 components. And I ran out of code space here. And that's why I started going with the other things. But I'm not sure how to do it unless it's the same thing where I'm just the left and right idea and then the sensor also goes in there and then each one send it out, but I'm not sure how that works. But here, let's try. If you look at the list of components, you should have an XOR component. I don't have an XOR component. There's nothing everything else is not recommended. Is that the XOR? Okay, so we have microcontroller, IO expander. So this reads 3 on-off signals. Wait, audio one? No, we haven't gotten to an audio one yet. So these are all the ones we've done so far. So we had a security camera, which was this. Replacement factory module, which was this. Then we had to play the game. Pulse generator. The above one is the audio one. Oh, the rubbish audio thing? Oh, okay. Oh, yeah, these were in here. These were allowed. Oh, interesting. Yeah, no, we didn't do that at all. I just wrote the code to do it. And it just worked. But what's interesting is that in this one, all these parts are available to us. In this one that we're working on, it is part not recommended. It only thinks that we need these. Which is interesting. Yeah, and their entire thing was like, okay, yeah, you have everything now. I'm like, okay, I know code. I could just do that. But I guess like the fact that it's throwing me off from the part not recommended. So if I were to choose one of these, I don't think I want a stepper. Oh, we have RAM? Oh, that's cool. Was it that first one that was the IO? Okay, yeah, the first one. Let's go back and take a look at it. This one, right? So write a 3-digit number to any XBus pin to change the state of the simple IO pins. The 3 digits of the value written will be used to turn the simple IO pins on, 100, or off, depending on if the digit is a 1 or a 0. Read from any XBus pin to get a 3-digit number that captures the state of the simple IO pins. The digits, the resulting XBus value will be set to either, okay, so on or off. So you're reading, oh, from any of these. Okay, so if any of them are true, okay, yeah, so if you're 100, oh, interesting. Okay. So if you're 100 coming in here, I assume that these are all 3 at once, like year 100, year 11, year 000. So at that moment, no, I'm confused by this table, this example table. Because like P0 is 0. Why are you 100 0? Like, why are you 0 if you're not? Pin is on or off. 100 is on, 0 is off. So you're 100, you're 100. So 0 and 1 is 100, when this would be 0 coming in? Is this not the one? Is this not right? I wonder if they changed the puzzle if people had trouble understanding this early game. Possibly. Like maybe. Or maybe they changed to say like, hey, don't use that. But we can't really ask them anymore, which is unfortunate. There was a smaller version of this, right? Like, it's really hard to see. Like, okay, so there's that thing right there. Oh, that's... What's... Oh, you're... Oh, you just have more P's. You have just more... Oh, you're all X's. Okay. You're that's the RAM. That's the... Okay, and I can set that to be read-only memory. That's a OR gate? Or that's a on or off gate. Oh, this is an if gate, right? Oh, wait. No, okay. I was hoping that, like, that maybe this would give me more information, but no. Oh, we got the different symbols for like and or, and I don't remember what those. Okay. Let's go find one of those. No, okay, hold on. You don't know them? You work with European symbols? Okay, so this is all just information about the puzzles that we're going to be doing. They have the sign right on them. These signs? Oh, like an and for, oh yeah, we don't have that. Why would we have that? That's an interesting, we don't have that chip. Are these the chips? These are LC. Okay, what are these? Maybe. Hold on. Okay, you are LC70G04. Yeah, okay. Okay, you wanted the LC70G86. Here's our XOR gate. When measuring inputs, signals less than 50 are interpreted as off, while signals greater than or equal to 50 are interpreted as on. Okay, so they both have to be greater than 50 to be on, right? So we need one of these now. To take in the time. Okay, so if we take in the time from this, but we still have the problem of what if it's greater than, what if it's less than? Unless there's like a math thing to figure out that without having to check both sides. You're on the P side, so I can move you down here. Now we have our on time and our off time. Oh, ad break just started. Sorry about that, everybody. I completely missed that it was starting soon. And so if I put you here, we can do, actually I could just do something like this. So, okay, so if you're coming out like this, and then our result you are both P's though, so I'm not sure how this is gonna work. Yeah, I'm not really sure how we're going to use this. Because I need to check to see if the time is greater than or less than for these. Oh, you thought it was an XOR, but it was wrong. It was 100% the first chip we looked at, which was this one. So this is the DX300. Yeah, this example table is very, I don't understand how to read this. Because these must not be the inputs here, but these are the outputs? But there's 3 inputs. Oh, these are 3 rewrites. Yeah, I guess I'm confused about how this chip works. But we can play around with it. But yeah, we need to know how this works in order to like sort of understand what it is. So I guess what we can do, let's Let's play around with it. So these are all X's that come in. And these are P's that come out. I can't do something like that. So if I want to write, you only need one going to the alarm. I need the sensor to go to the alarm. If the other things are true. Oh, is that what it is? I have... Okay, so I do something like that. Wait, no, that doesn't make sense. I have those two already going. So then sensor pin mismatch. But these are both IO. Like I can go in out on these side too. That feels weird. So I can do something like that. You go out. Unless I want to convert the sensor to an X. Maybe that's what I want to do. Oh, is that how this is working? Or is this actually inputs over here? So if I put in 0, 0, 0, we're gonna get, okay, 0, 0, 100, we get 100 out. If I put in 100, 100, 0, we get 0, 11 out. Otherwise, 0, 0, 0, we get 0 out. The 11 here is weird to me. Okay, the resulting X plus value will be set to either a 1 or a 0 depending on if the simple IO pin is on or off. Okay, so if you're on, you're a 1. So okay, so it's actually like 1, 1, 1. This chip allows you to control 3 0, 100 input outputs with a single connection. A single connection? Wouldn't it be 3 connections? Or up to 3 connections? Okay, so this goes out to the alarm. And then I need to convert something like that. They don't do anything special except allow you to connect multiple controllers. Okay. So then you come in here like that, and now I can control. So if I move that out like that, Now for this, I would need to send in based on if you are, I still need the thing where I'm sending in a 0 or 100 based upon if it's greater than the on time, less than this. So like if I do something like you, I still need to test to see. XBus is close to the connections in TIS 100. They're a blocking communication channel. Isn't everything blocking here though so far? Okay, so we need it to handle the case where time is less than, right? So, oh, the simple IO is not. So the simple IO on the right-hand side is not blocking, this is blocking. So if I test less than x0, x1. Okay, you can use it even if nobody is on the other side. Oh, interesting. Drago, welcome, welcome, welcome. How are you doing today? And thank you so much for the raid. How's your stream? You're doing good? Excellent. That's good to hear. It was okay? Well, that's good too. You have a new symbol. So we're working on, oh, thank you so much for the bit too. We're working on this Shenzhen I, which is a electrical engineering puzzle game. Fan noise again? Oh, okay. Maybe it's just because of this game. Let me try turning the mic gain down a little bit more, maybe 1 more dB. How's that? Let me know if you can hear fan noise. It's now down to -5. No, I can see it still hitting. Okay, let me try. Wow, it's still hitting with that. -6. -7. Okay, that might be good. We'll try this for a little bit of time. And here, I'll bring my voice a little bit up to recompensate. Okay. I should be back to where I was previously. Let me know if my voice is too loud or if you hear the fan noise again. All right, so what we want to do is we want to send out okay, so read from any XBus pin to get a 3-digit number that captures the state of the simple IO pins. No, right. Write a 3-digit number to any XBus pin to change the state of the simple IO pins. The 3 digits of the value written will be used to turn the simple IO pins on or off depending on if the digit is a 1 or a 0. Oh. Okay, I see. So this is all 3. So if I turn on, this is 1, 1. So this one is off, on. And if I do that, you're 100, 100, 0. Okay. Oh, interesting. Okay. Not sure how that's going to help us. Because I need to read. I need to read from the sensor, but only if it's within the time here. So yeah, okay. So if you're less than this, then we just want to test to see, okay, if okay, so I don't think the sensor goes in here. This is probably going to be something else around here that we're going to deal with. And you're not going to go out. Fan noise again? Huh, interesting. Let me try. Eight down to -8. Hey, we want the best audio possible, so hopefully this helps. Okay, so we have you. If you're less than, okay, so on time is less than off time, meaning that all you need to be is greater than this. So if you're okay, so at this point in time, we now want to, I need to do another if. So this is why I was doing the previous multiple chips, right? So if this is less than that, I now want to check to see if you're greater than this and less than this. Is that true, or do I want to just check to see if your number is greater than, because I can just send out to here. TEQ is your friend here. You'll need 4 of them, and that's all you need. TEQ? Is that a part? Oh, T equal. Yeah, okay, never mind. That was... Wait, why do I need T equal? I'm not sure how T equal will work here. Because, like, we don't want to see if things are equal to each other or not. Who's Taniqua? T-Equa? Yeah, I guess I'm really confused by the idea of t equal. That might have been too much of a hint, but it's really confusing to me because how would I do t equal when it has to be any number between them? I can't do t equal to all of them. Unless we're doing, so the thing that I was talking about earlier is there like a math thing that I can do where I can just subtract the times? But like in my mind, math is not really a strong point for me, so I don't really know what that math would be to figure it out. You need one t. Well, I was using t greater than to test this out first, right? So like if we do t greater than or t less than to do the opposite logic, right? So if we say, okay, I want x0 and x1. So now we know this on time is greater than the off time. And so in this specific case, I want it if it's greater than, okay, so if this time is greater than you, turn you on, maybe. So then I have to do another greater than. So I needed t greater than p0 x1. Now it's a plus for this one. And so if that's the case, and really I want, oh, I can't do math with this. I need a t equal and a t greater. Or I can move p0. Let's actually move p0 to ACC up here. Okay, so if you're greater than this, I don't know if I figured it out yet. We'll find out. Move. Okay, so I don't want to move anymore. I want to check to see. Okay, if p0 is greater than this minus, so we want to now. Maybe I want to move this to data, so I actually keep it. We want to move dat to ACC sub 1. If t is greater than ACC and then the on time, which is x0, then we turn u on, I guess. So we send a 1 to here. So we move 1 to x3. Now the problem that we found is that a minus here is a minus for either of these. So if it minuses to this one, it goes straight to here, but it's also like not to this one, which is not great. Because it's not always on. It can be off. They both should be off at some point in times. Oh, so I just don't do a minus then. I have to do just another one, another test here. So t a t less than x0 x1. So if we're here, I want to add one. So now we move that back to the ACC. Well, and actually, if we no, because we need to handle the other case too. Because I'm not done with this. I'm not done with this first one yet. It's like, okay, this is, if you're greater than this, okay, so if you're greater than, then I want anything that's above it. I guess like I don't understand how it's handling the logic for me. Like I don't see that. Because it's just one on and off, right? But how does it know that how do I know to send the one here? How do I know to send the one here? Because I don't have a one or not. So like basically I need to say like, hey, if this time is greater than this and this. But this isn't an XOR. This is just going to turn this on or off, which is not helpful to me as far as I can tell. Obviously it works for you, which means that it's just me not understanding how to do it. So it's not true that it's not helpful. It's more of like, hey, I don't know how to do it. Or rather, I'm not thinking in the right ways. Like I'm still stuck in like whatever programming mindset that I have. And I haven't had this shift yet. Because, okay, so if we test to see, okay, if you're greater than x0 to x1, I now also need to be able to send like, because here's my thoughts about like how to use the chip. I need to send a 1 here if it's greater than the on time, and then a 1 here if it's like less than that, but that's only if the on time is greater than the off time. But if it's less than, then I need to send a 1 down here. At least that's sort of like what my mental model is right now, which means that my mental model hasn't shifted at all knowing about the chip. And then I guess like from out of here, if we have another chip here, oh, but how do I deal with this? Because these are always, it doesn't come into one. It doesn't collapse or reduce into one thing. It's each one is going to be on or off. And so I need to test those along with the sensor and to grab it out. I mean, I guess if I were to just do, if you're greater than this, what? Okay, so the time doesn't come out here at all and doesn't get used in this thing. Let's imagine that maybe, I don't know. Okay, so you're both, let's say I put you in here. What if I only used you as, okay, so let's use like the X. So what if I used you only as, if you're greater than this, you throw into there? Like if I do t greater than x0, x1, we're gonna move 1 to x3. Otherwise, we're gonna move 1 to x2. As far as I can tell, all that's really going to give me here is, now you're going to be activated as 100 or 100 based upon which is greater than, but I don't have the time anymore. I've lost the time. So that's not helpful. So I need more logic in here to turn these on or off. So if you're greater than, if you're greater than this, I need to test to see if you're also greater than here, which means that's another test greater than, well, actually I need to do less than equal to this. So if it's, oh yeah, that's okay. So we need to move x0 to ACC sub 1 sub 1, and then we can do another test greater than, and I need the time, so it can't be this, it has to be the big one because I just need more inputs. And you're a P input, okay. So if I do something like this, then we'll do the same thing again. So we'll say, let's go ahead and, well, I don't think I can do the move yet. So we're gonna test greater than x0, x1, yeah. So if you're greater than, we also want to test to see, okay, now if we're gonna move x0 to ACC sub 1, test greater than P0 ACC. So if you're greater than that, if you're greater than that, I want to send something out of x3, let's say. Otherwise, just nothing at all. It's a 0 by default, so that'll be fine. So then I want to test. I cannot do a less than because that will be this one. So I have to test less than x0, x1. So for here, we're going to move x1 to ACC, sub 1, test less than no wait I'm missing the other entire case for here. Wait, so that won't work. So I'm only testing if it's greater than on time. I need to also test that it's less than off time. So at this point in time, I also now need to say test less than x p1 no p0 x1, because if you're there, then we're going to move 1 to x3. Otherwise, we don't move 1 to x3 at all. Okay, so there's that. Now we test the other one. So now we can test less than x0, x1. We move x1 to ACC. We add 1. Wait. Before I just blindly do this, let me go through with my mind. Okay, so now on time is less than off time. So now I want to test it. It's greater than. Okay, so I want to test. Okay, we still need to. Yeah, too bad the music loops too frequently. Yeah, that is too bad. And it's too bad I don't have any other music that I trust to play right now. And also, if I play any music, it will go into the recording because the game is going to the recording. Okay, so this is wrong up here. So this is sub 1, but then test less than this. I also, need to move x1 to ACC, add 1. Then we test less than P0 ACC, and then that moves out there. And now I need to do this entire thing again now for the other case. I don't have enough room for it. I guess I don't know how to get to those 6 lines that you're talking about. Like, unless there's some math that I can do with the on and off time, which I'm not aware of. Like, the only thing I can think of for math with the on and on time was subtracting like on time from off time and then comparing that to P0, but I'm not sure how to do that. I'm not sure how that works. Like, I think I would be missing a step in there. So I still feel stuck. Just think what happens if the time is equal. What would you send? If the time is equal, if the time is equal, we move out to the next phase, right? To then check the sensor. You just need logic for, but don't I need also the opposite logic for what happens when on time is less than on time? Sorry, what happens when on time is less than off time? That needs to be handled too, when that's exactly the opposite logic. Unless I'm going to use a bunch of these. Yeah, I guess I'm not sure how I would do the t greater than or t less the t equal. Like how they actually work with the on and off times. Because it would be checking to see if t equal for the time, right? So if the time is equal to on time, yeah, we're on. If the time is equal to off time, yeah, we're on. I need to know the betweens. If it's between. But the betweens are different based upon if on time is greater than off time or not. I mean, we can basically start that up and we can say like, okay, let's say if it's t equal p0 with like x0, then I want to, I don't know, move 1 to x3. And then also I can check to see if p equal p0 x1, move 1 to, do I want that to be the same thing, x3 or x2? Be like x2, right? But now, what do I do for the rest? So like if it's greater than this, that should be on, but only if it's greater no, that should be on, and then so yeah, this is where I get confused. Because like, okay, so if it's t greater than x0, x1, if this is greater, then I just want that to be greater. So I have to do another test. So another t greater than. You're pretty sure they had to remove this chip from recommended because it was hard for people to understand early game? Yeah, that's what I'm having trouble with, yeah. So if P0 is greater than X0, if you're greater than that, now it's go time again. So, but this would, I guess, like, I don't really get what this is doing for me. Like move 1 to like x2. I guess we can move this to x1. and then these are the other ones. So then, but then, okay, so you have to be greater than this, but you also have to be, so I can't move yet. You also have to be t less than t0 x1. If you're both of those together, then we're going to move 1 to x2. And now we have to do the other way around, right? Now we have to test to see if t less than x0 x1, t isn't anything always greater than on time going to be on? I think so, right? No matter what, if on time, if it's like 94, 95, but even if this was like 24, oh no, that's not true, because then it might be less than this. So it's gonna have to be both. So if okay, so if t less than, okay, so we're in the less than, so now I have to check. Okay, so you're greater than p0 x0, and you have to be now t less than p0 x1. In that case, we're going to move 1 to x2, no, x3. So if we do that, now both of these will turn on. Okay, both of these need to be turned on now, right? If they're both 100. No, if either of them are 100. Yeah, we read the example and I got really confused by the example. The example table here. Basically it's just like if it's whatever these are on, then these are on here. So it's just a 1 or a 0 coming in. So that's I guess I didn't see like an oh, the example circuit. I didn't see that. The following circuit controls a stepper motor using micros DX300 digital I/O expander to control motor 0, motor 1, and motor 2 signals. Which is not what I want to do. That's not what I'm doing at all. To control the braining. Okay, so oh, that's weird. Oh yeah, that's not what I wanted. That's not, okay, so I was thinking that each one was in here, but I could have 3 inputs that are each doing those. That's definitely not what I'm doing. Wasn't there a way that I can control digits within a number? Oh, but that just gets it out. No, this sets. Wait. Okay, I want to set DST. Okay. So if we start with saying we assume that we're on, so if we move 011 to ACC, at the very end we're gonna have to sleep 1. Then we go through the logic to see if we should turn it off, right? So if you're equal to that, we don't move. We just set. Well, actually, we don't have to test equal or not, right? Like if you're equal, you're already on, so I don't need this at all. And the same for you, because we're already assuming that you're on, and it's really if you're not equal that you're on. So we want to test the opposites at that point in time. So that goes away. So if you're greater than, then I really want to test to see if you're now less than. So if you're t less than p0 x0, we're going to do digit set what's the t mean? DST, what is it, 3? Okay, so starts at 0, so 2. So let's do the first one as this one, right? So 1, 0. But then we also test to see if you're greater than, test greater than P1 X1, and if you are, then DST 1, 0. So test both those together. Then one more thing of fan noise. Okay, let me try it again. All right, down to -9. We'll try this. Okay, so then we test less than. Okay, so now we're testing if on time is less than this. So we're going to do the opposite now. If you're less than the on time, so if TLT test less than x0 p0 x0, DST 2, 0, test okay, wait, so logic. Should I really just be testing if you're greater than on time and if you're less than on time? Off time? Now I've forgotten all the logic stuff. So let's try that. Let's just say, okay, so we're starting with ACC is 0, 1, 1. So we assume that everything, that both of them are on. Okay, so oh, I'm glad you got your train. That would have sucked. I want to do the move yet. So okay. Hold on, let me walk through this again because I got my brain just immediately forgot everything I was doing and completely reset. So we start with 011 being here in ACC. We test if you're greater than you. If you are, we also test if the time is less than the on time. Now, if the time is there ever a time where the on time being less than the off time works? No, right? So like it's always just on. So should I really start with 0, 0, 0? Like we just have 0, 0, 0 in ACC. And then if we say, okay, let's start over again. We'll do our t equals. So if we t equal p0, x0, I want, we can just do, we'll just say, hey, this top one go. So in that case, that's going to be DST01. So we'll have the t equals be the top one, right? So DST, then we'll do t equal P0 X1 DST01. Renato, hello. How are you doing today? Oh, ad starts in 2.5 minutes. I'm glad I looked over to check that out. I'll be actually taking a real break during this one. Okay, so DST. Okay, we're good to go there. I want to okay, now we check to see if we're greater than on time. So test greater than P0 X0. If we're greater than on time, then let's DST 1. And I guess we could also check to see if we'll just do this as if we're less than off time. So LT P0 X1 DST 2.1. So we just do those tests to see, like, hopefully we're between it or equal to it. Then we want to move ACC to X3 and sleep 1. So if that's the case, then we should see these all set appropriately. And I think that if I advanced, this got set to AC. So this is still okay because you're 84. You're 84, you're 93, you're 38, you're less than the on time, so this will be 0. Okay. I sleep 1 and I go over again, and so then all of you, you're not actually showing me Oh, I would really love to see if these were on or off. So now I need to take these and read them in. I only have 2 P's in here, which sucks. Everything else is X's, and everything that I need is a P. Oh, that's not great. All right, the ad break just started. I'm gonna go and go take a walk around, and I'll be back in 3 minutes or so. So I will see you then. I also have this thing. All right. I can make the break smaller. Maybe I'll put this down here. I will be right back. Oh, is the break done? Nice. Excellent. Hopefully I didn't leave you all waiting too much longer. Okay, let's try to continue on. So I don't think I can use all 3 of these. because I just don't have the inputs for it. These are all X inputs. Unless I flip this around and I do something like this. These are P inputs, and then these would go out as actual values, and these would come in as like ones and zeros, right? That's how that works. Yes, you only need one output coming out of here. Okay. So we just do this. We'll do that. So you're going to be, okay, so you start with 0. And then I'm going to, this has to be the third one. So always set 2. Always set 2. So this is 2, this is 2, that's 2. Okay, so this comes out of here. So then let's move P0 to ACC. Here, I just want to see what this is. So if we step through U, now this first one, why did it moved this in here right away, didn't it? Okay, so you have to wait until this becomes, okay, 93, so this will be 100. Why are you 100? Shouldn't that be 001? Yeah, this went out there. That's not what I wanted. Oh. DST 2. That's still 100. That's not what I want. Which is sending out of here. Okay, so my DST didn't do what I expected it to. I thought it was gonna write the furthest digit of this, but that's not what happened. Oh, what if I do something like that? That should have set it to 1. So you're not equal anymore. You're not equal. Wait, you were equal. Because you're 93. So is 93 equal to 93? Why does that go into here? It does go into here. Okay. So then that should set this to 1. That should set this to 111. It doesn't. Okay, so DST doesn't work the way I expect it to. Set the digit of accumulator specified by the first operand to the value of the second operand. Yeah, so I want to say DST, so like 596, DST2, 7. I want this to be... Oh. Oh, it's counting from... Okay, so... I dyslexized it. I want 0. There, that's 1 now. Okay. So if you're 1, okay, so then we check to see test equal ACC 100. If you are, then I want to read in the sensor. I don't need the ACC thing. I can just say test equal to P0 to 100. Okay, so if you're equal to that, then I want to test to see test greater than P1 20. So if you're greater than 20, then we move you into here. No, then we turn this into a 1-0, which means I need this. So now to convert this out, okay, so if you're greater than 20 now, then we set you to alarm state. So we move 100 to X2 and then reset. Otherwise it's moving 0 out. You are going to just move X0 to P1, sleep 1. Would this work? What's the chance that this works? Nothing. Flat dead. Okay, cool. It's always an alarm state. Oh, I'm always moving this out. I missed. I need that, don't I? Wait, why aren't you sleeping? Blocking on read. I thought it would wait until this had something sent out. Oh, because this might not send anything at all. So if this is a... Okay, so what if I do a minus, move 0 to X2? Okay, so that's pretty good, except I'm missing this one right here. So in this case, we're about to have... Time is 93. Okay, so you should be equal to... So we set that to 1, so we set you there. Oh, why? I'm like off by 1 air with this. Like you've already moved through. Maybe I do want to move. Oh, and I don't want to send anything out because it is constantly reading this. And so I just don't want to send anything out at all. So I don't need that there. Instead of moving 0 to 2. Maybe I do want, wait, do I need to move 0 to 2 or do we just want to jump back up to the top? Okay, so if you're equal to P0, okay, so if you're equal to 100, then we move into here. Oh, so if you're not equal to that, I jump back to start. And we go there. And that just reads it forever because, okay, so that's not going to work. So I can't jump out to start. I don't want to send it to 0, right? I can't send this out to 0 because then it doesn't know if it's really there yet or not. I need it only when this actually hits. So now we run into that asynchronous problem we were talking about before, where this is reading constantly from this, regardless of input coming into here, which kind of sucks. Let's see, so I only want to send something out here. I wonder if, because I have to have this thing anyways, because of the ports. I wonder if I just send you in here like that. And we reset you a little bit. Still fan noises? All right, let's see what I can do. How about another -1 decibel? So we're at -10 now. We'll see how this is. Okay, so this is always going to be 100 or 0, and I don't know if a tick has happened. Unless I need the time also to come to here. And we could do that. That feels like that might be me overcomplicating it again, though. So let's say I do need to... Okay, so if I have the time in here, I don't think I can send this to 2 places at once, right? Oh, can I? Does that let me do that? Here, let me try this. Move P1 to ACC. Sleep 1. Oh yeah, I think that does let me do that. Oh, okay. Okay, so this will work. I want to move P1 to ACC. All right, well, thank you for hanging out, Albert. Hopefully you have a good dinner and sleep and night. And thanks for the feedback for the fan noise. I'm hoping that this improved it quite a bit. Okay, so we move P1 to ACC. So if we do that, then I want to now, save. So I probably save it. It's like also move P1 to DAT. So I have, no, I just need P1 to ACC. This will be fine. I can compare it to later to see whether or not I should move on from this. So the first time we go through this, we then check to see if you're 100. So if T equal T0, if you're 100, I want to move now this is just moving. Oh yeah, this is moving the this down here. So I just want to move 100 to X2. Otherwise, move 0 to X2. And then I need to test okay, so let's not move this at the beginning. If we have, okay, so if T equal P1 and ACC, if you're equal to that still, we're going to jump we want to jump to skip. No, jump to start. Okay, jump back to start. Otherwise, we continue on through this, right? So infinite loop here until like it goes. Then we do this one time. And so now we say, okay, we're going to now, let's just move. We don't need to move into, okay. So if you're equal, T equal X0 and 100. So if you're equal to that, then we're on. And so now we want to move the sensor So t greater than 20 p0. Is p0 greater than 20? And if it is, then move 100 to p1. Otherwise, move 0 to p1. So if you're not, move 0 to p1. But if you are, move 100 to p1. And then we can, do we want to check anything else? Oh yeah, I do the same thing here. So minus, move 0 to p1. You're not sleeping. Oh, do you need to sleep? I'm off by, no, that's wrong. That's very wrong. So you're not sleeping ever. Do I want to jump to start? So maybe I sleep 1 and then jump to start. Oh, I wanted this. Oh, because, okay, I need to start this wherever this is. If the ACC is 0, so if the ACC is 0, I want to move. I mean, but we might start with like on. Oh, this is okay. This is not working. I need to do that at the end, I think. So we just assume like, okay, the first time we're not there, right? So we're not just jumping to start. We just check to see, okay, if you're equal to 100, we're good to go. Move either 100 or 0 out. Sleep 1. I do want to move P1 to ACC to store what we've got. Well, I guess like I still don't know how to properly use it. I might as well use it. That's true. Like I am not using it properly. It's probably actually making it harder for me, isn't it? So at this point, I could go out like this, and then we can just say this. What am I going out? Yeah, I'm going out of X3. So let's say I move, if I test equal x1 to 111, let's say. If you're equal to that, then I want to move 100 to x2. Otherwise, move 0 to x2. Sleep 1. Would that be enough? I'm like the opposite. on some of them. So here, okay, so here on this, we should be turning on because we're equal to. So I'm testing, I'm waiting for in. That becomes 111. We're gonna move 100 to X2. Okay, so 100 X2, then we wanna see greater than 20. Oh, it's greater than or equal to, isn't it? So it's test equal to, oh, the easiest thing to do would be to switch this to 19. Okay, so that didn't work. Okay, so we get, you're in here, we're gonna write 100 out to you. So we wanna see if you're equal to 100. Now we check to see if 19, did I do this backwards? Should it be P019? That should be. Okay, that works. Okay, so here's our scenario. We have 44 as our time. 44 is less than on time, so that should be off, right? And that's what we have here. So why do I turn on? So, okay. Are you equal? Is time equal? That's false. Is it equal to the off time? False. Is it greater than on time? False. Is it less than off time? True. Okay. That's why it turned on. So the logic here is flawed because I need to I need to be greater than on time. I must be greater than on time. So should I reverse this? And I want to say if you're less than this one, maybe reverse you? Oh, let's oh, I can't even go to the next page in here to turn off the breakpoint. No, it's okay, so this still turned on. It was supposed to be off. Okay, are you less than P0? True, so I set that to 0. Okay, oh, I set it to 1, and then I test to see if you're greater than that. I'm not, so I need to set this a minus. Back to 0. Nope, that logic doesn't work out. Yeah, so this is, yeah, okay, so this doesn't work. We're back to the start again. We're run out of code. And so this is where like the DX300 is supposed to be helping me, but I guess I still don't understand how to use the DX300 then. Because I'm just replicating it, I'm just doing it in code anyways. And like this isn't doing what I want it to do. I could do that. Oh, but I only have one output here, so that's not going to work. That's just silly. I guess like regardless, I don't understand how to only set one of these things to come out when the logic of the on time and off time is like I'm missing like an entire test case for it because of time, because of length of code, number of lines. We could try reversing it again and doing the other logic, but I don't know. Okay, so let's try that. So, which I guess, yeah, is the same thing as like not having this at all. So if we start with, we have everything. And now I want to test. Don't forget the big chip has 4 inputs, so all 4 sensors are going into it. I have 2 big chips. And I don't have 4 sensors going into it. So I'm not doing that. I'm not sure how to. I guess that's where my, okay, you have X0, X1, well, but I don't have those. Like I could do those, but I'm not. And I guess that's the problem where like I still don't sort of get how it works. Like it's one of those things where I'm not able to shift my mental model over to it to like see it. So I'm kind of like stuck, or it's not, maybe it's like not in my ZPD, and so therefore it's above where I'm capable at right now. I don't know if any of that makes sense. Okay, so if I reverse this logic. Then we want to just check the opposites. So if it's t less than p0 x0, we just set u to 0. If you watch the DX300, you have 3 logic gates and you only want 1 going to the alarm, if that helps you. But what I'm confused about is when you said that we only have 1 coming in and 1 going out of the logic gates. Doesn't make sense to me. Like, what's the point of this then if we're only using 1 of them? If we're using multiple of these, absolutely, that makes a lot more sense. You want the right logic to only go out of X3, which is, there is no X3 here. This is P0. P1, but it still doesn't make sense that it's only out of 1. What's the point of this if we're having 1 come into here and then 1 come out? Like, I guess like this makes sense when it's multiple coming out and 1 coming in. That makes sense to me. I just don't get the other way around. Like, I can't see it in my mind, or like logic through it in my mind, because I guess it's unfamiliar enough to me that I don't have like a, the way I keep on coming back to, like, is the mental model, right? Like, I'm having trouble wrapping my mind around it because it's outside of like familiarity for me. Because this means I have to create logic to send 0, 1, 0 out or not out, and that's it. But then I'm doing all the logic here then to chew this. This old school logic, you need to think of how programming is done. It's doing the same thing that chip is doing. The chip is just taking in a number though, like 111, 101, 000, and then turning these on based upon that. So like, I don't see, there's no logic that's happening here. It's just based upon the binary number coming in, it's just these are on or off. But if I'm only having 1 go out of here, I only want 1 state coming in, or not at all. So what's the point? Like, that's where my mind is right now. It's like, then what's the point, right? Because I could imagine a solution, maybe, possibly, where I could say, okay, if it's greater than on time, or like to do that math and then say, okay, if it's like in this state, like send out here, like make this on, and then also make this on or off too. And then I can check to see, okay, whichever, like the combination, like maybe I do an and or something. If you have something that doesn't need to set the alarm, you can send it to P2 and P0, it would be dropped. Okay, so I pretend that I have traces connected to here, and I'm only caring about that going out. But that's the same thing to me. Like there's no difference between just setting this to be, because I still need to set the number here to set it out. And whether or not I set that or not doesn't matter. Right? Like, I guess I don't want to, hope I'm not saying like I'm arguing. It's more of like, I don't get it. It's hard for me to move forward without having something to get, if that makes sense. Because yeah, so like 111. So like this adds, so right now this is sending. It's going to send a message out here, here, and here. So it sets these all to 100. I only care about this one to do the alarm out, right? A better example, I guess, like in this for this specific case might be helpful, right? Because then I could say, okay, yeah, we have because okay, this is interesting, and that lets me know in general how it works. This, however, is showing how to do stuff when all three are needed. But yeah, this is like, I guess the problem with using this to sort of understand how it works is it's such a different domain. No, not domain. It's such a different context that it's being used in that I can't transfer from this context to another context. Or rather, I can't transfer to specifically this context. And so in that case, like, I'm not even using it because it's so far outside. Like it's just the transfer itself, which is an educational term. Fun fact. It's where you can take something from like one context, like, okay, here's like an example of how it's used, but then now I can use it in a different way. That's transfer. And so I'm failing to transfer at this point in time using that because I just don't get it. It's fun. If I want to do the same thing but like opposite, which if I remember correctly, this is the problem that we run into, which is like greater than on time is always on. So what if we reset? So if we just say, okay, so if we do t equal e0 x0 move sure 1 1 1 x3 t equal e0 x1 And now we get to the point, okay, so if you're greater than on time, this will kind of work, right? So like, if you're greater than P0, X0, I also need to check to see if you're less than the on time, unless I need to set, I need to maybe like do some data or accumulation stuff before I would move forward with this. Okay, so I don't think I can do P001 straight up. I think we're gonna have to do target greater than X0, X1. So if you're greater than that, or rather, what if I, oh, okay. We have some more information. Not sure if this table does a better job of explaining it. Go away. The DX300 has 3 simple I/O pins in one side and 3 X-bus pins in the other. Each side can be in either input mode or output mode, and the part's behavior depends on the request to each pin. It also has 3 internal flip-flops that can be set and read by both sides. The names of the internal flip-flops are not documented, so they will be called P0, P1, and P2, as each one is directly linked to one simple I/O pin with similar name. The X-bus pins names are also not documented and will be called X0, X1, and X2. Each simple I/O pin is directly linked to one flip-flop and can be used to set it. The signals are treated as digital, meaning values up to 50 will set a flip-flop up to 0, and values above 50, okay, well that did not say that at all. Oh, okay. Oh no, but that's a simple I/O pin. That's these ones, okay. Maybe they did say that. That's if I reverse it around and do the other side. Do I want to do something like that? When an X-bus signal writes to the DX300, each digit of the number will set a flip-flop. The ones will set P0, the 10s will set P1. Okay, yeah, that makes sense. When a read request is sent to the X-bus side, the DX300 will output a number in the form I don't know if what that really means. Okay, there's not really much else there. And they did confirm that it was recommended at the start, but they pushed it back to later levels. Interesting. Okay. This felt like more, right? Like there's not really examples here. I guess there's examples of pins. It felt like more on the P side. And is that what I want to be using? Do I want to... Do I want to do this? I cannot do this. Because I only have a P here. So I have to do it this way. Because I at least have enough. Because that only makes sense if I'm writing to multiple at the same time. But it's the same problem. Like that I don't think that really helped me because I still have trouble transferring this. Like I have trouble reading the table and like then imagining what this means. At least in like this specific use case. It just is how it works, but we know how it works now. So I know how the chip works. I don't know how to use the chip in the context that I want to use it in. Does that make sense? So I guess, ad starts in 2 minutes. I'll probably take another break just to see if I can get my mind to work subconsciously with the transfer. Maybe that will help. Okay, so if I move 100 to ACC, so let's say we move like we're on to ACC. We said that 100 is on. And actually, what if we just say everything is on? Maybe we do something like that again. We just do like, okay, we're on, and then I can do some more logic over here. And so then I want to turn off if it's off. So if we test so I want to do something like this. I test like, okay, if on time is less than off time, which is sort of like the normal thing that we normally would expect. Yeah, so if on time is less than off time, then I want to turn this off if on time, okay, so if test so really the first one would be if test less than P1 X0. So if P1 is less than X0, we're going to we overwrite that digit and say that you're 0 now. I feel like maybe I can do something with binary here. Oh, ads are starting any second now. And then we'll take another quick break. You already did the audio one. If I gave you the recommended solution they have for that one, is that kosher? Yeah, we can go here. Audio. Rubbish audio thing. So yeah, so here's this design. This is what I did. Can I copy the design? I can. If you want to give me that design in Discord, I will copy it into here and we'll play around with it. I'm going to take a quick break though, in the meantime, to reset my brain. So I will be back. Oh, we have that. Cool. Okay. We're going to come and play around with this, and I will be back shortly, and we'll break into this and take a look at it and see if this helps me or not. So I will be right back. All right, we are back. The DX300 is flipped for this one, but hopefully it'll give you a gist. Yeah, well, I guess like flipped means it's very different logic at that point in time, right? So it's gonna be a different mindset, but we'll see. Because as we're seeing here, I need to remember how this works. So we'll just implement this and try it out and then break it down. So we're going to take in the DX300 and then put maximize into it. And if we were to look at this, it's actually just Let's see. Maximize is simple input connected to a switch. Right, because that maximize is on or off. And then we have audio in that's coming above a certain amount. Right, and then I do the little thing to move it around. So yeah, if we do this thing, flip it around. We did something like that. Yeah, you drop this into P2. And then that is going to go out into one of these chips. And then your audio in also comes into here. And then we have P1 going out here. And so now you're okay, so test. What was TCP again? Compare the value of the first operand to the value of the second operand. Oh, it's just compare. Okay, so if A is greater than B enabled, equal is disabled, okay, so it just checks to see if it's equal, greater, or less. Okay. So you're comparing, okay, so compare X0 to P0. Now this will be X0 to P0 because this will flip it. It only flips it on if it's greater than 50. So if this is greater than 50, this becomes 001. And then you'll multiply by 4 and sub 150. Otherwise, we won't do that at all, and you'll just move it out. Okay, so now I'm curious. Okay, so if I let's move X0 to ACC and just see what we got. Yeah, you become 100 and you're 0 and then you're 100 because maximized turned on. So yeah, and you're 100. Hold on, can I go a little bit further out? I could actually see this, right? I was really hoping I would see that this is like 100 here, sort of like how they show this is 49. I guess I can see that this is 100. Now I'm curious. Is that going to be the same thing? 10. Right. This is where the reading from the XBus is different than writing to the XBus, which is the one table A gave me. Right, but I have to do it reversed. Because like coming out of here is just gonna be 100s reading out, where I'm putting like 110 or something else in. So if I do this, like if I say like, okay, I move, let's say you do X ACC, if you're 10, so now, okay, I just check to see if you're, now the audio, how did this work again? It's just a simple input. You were initially comparing it to see if it was equal. So you're testing, okay, so if you're equal, like you're comparing it from out of here to here. The audio in, this is always going to be 0 or 100. It's gonna be 0 or 100. That's pretty much it. So instead of comparing it like that, wouldn't you instead though just say like t equal 100 x 0? We've had to move P0 to ACC, and if you do compare favorably, then we do the what, like the multiply? Oh, I can go look at the thing, but it's just what, multiply by 4 sub 150? Yeah. So, well, 4 sub 150. Move ACC P1 sleep 1. Like, wouldn't that be the same thing though? No, it's close. I'm not doing anything at all to it. No, I am doing something to it. Oh, and it's not 1, it's 10. Yeah, okay. However, this isn't giving me anything special, right? If I were to replace this, I guess you're a P, so I would just probably didn't want to do that. No matter what, it's the same thing. I guess I just need... Oh, cool. I can undo everything. Oh, that's nice. Really, so if I move this out here and instead I just change this one piece of logic here to say if you're equal to 100, it's exactly the same thing. It's like, to me, this doesn't, like, that's the way, like, I see that and transfer that is like there is no difference in just like taking it. So I guess, like, to me, okay, so somebody else did it with that. Got. Let's close you. Put you here. Also put you here. Okay, so this is... Wait a second. Drinking game. Okay, so we have those. Okay, so we're using... Oh, I haven't used Gen yet. Yeah, so we have different clicks going to this, but then you are just move you out to here. Okay. Yeah. And so to me, this is like, this makes a lot more sense for this device, right? Because we're using all three of them. And we want these to be on 100 or off 0. Yeah, I kind of went outside the box with this one. I can see that. Oh, right, because this is just every other one, and so this is a not gate where it reverses it. If it's true, it's don't do it. If it otherwise, do it. But yeah, this one makes sense to me because we're using all the outputs. What I still have trouble thinking about is why would we be using this if we're not using all the outputs, or at least more than one output? Maybe we could flip this around and use the P's coming in. somehow with the time and like sort of like add the time together, do some math. I don't think that makes sense, because I don't want it to just add. I want it to do something else. So I still feel relatively stuck in the same place, because I'm not seeing how I can take something that's using all outputs and put into a situation where I don't use any outputs. Because in here, if I'm taking one in to this, here, we'll just start a new one. If we're basically doing something along the lines of this, and we're just saying like, okay, whatever you go in, that makes sense, right? Because I'm gonna say, okay, move 100, move something else. But if I'm always just saying move 0 or 1, unless there's a math, and the thing is, like, if there's a math thing that I'm missing, and that's the problem that I'm having, I'm not even thinking about that. But if I could somehow like create a math thing, okay, so if I sent like move 200 to x3, this is what, 0, 1, 2? Oh, 0, 1s, 10s, 100s. So it'd be you. Yes, that doesn't come out of here. Doesn't come out of here. So yeah, I don't think it's going to come out of any of these. Oh, that does send it out there. Okay, that actually sends out a 100. Ooh, okay, hold on. Can I actually... Do we get to see that here? Oh, we do. Okay. So move 200 out of there. Move like... Okay, so what if I did something... What if I did something crazy? What if I were to say, hey, subtract on time from off time? So let's do move x0 to ACC, sub x1 move ACC to X3, sleep 1. That turns those on. No, I've lost the time. That's the only problem. I've lost the time. So I need to do something with the time in here. I don't feel like I'm getting the idea behind it though. That's the only problem. Because I don't feel like it. That doesn't mean I'm not going to get it. Fit, hello. How are you doing today? We're trying to. Okay, so how would I, like, what kind of math shenanigans can we do to use time within these two on and offs? You're grim though, but with strong motivation. Well, hopefully you're able to pull through in the end and whatever it is. Oh, and also I'm no longer on break. I can turn that off. I'm doing good, although this puzzle that I'm trying to work on is kicking my butt. It's kicked my butt for half of last week, the stream last week, and the entire stream today, which is not boding well for the game. You're making a to-do list for things you want to build with Rest and Rabbit MQ, and the list is becoming way too complex and big. Electrical engineering is hard. Yes, it is hard. It's not something that like my brain knows how to deal with right now. But in this case, this doesn't feel like electrical engineering. This feels like a math problem. And I'm famously bad at math, or at least so. Okay, I'm not bad at math. I'm bad at coming up with creative math solutions with like numbers. This is why we came up with microcontrollers instead of using circuits. Yeah. Am I a back-end engineer? No. Well, okay. I am an engineer, so I do programming. I don't have any difference between a front end and a back end, because whatever the problem is that I'm faced with, I will work on that. And if the problem requires solutions that are in the front end space, I will work on it there. And if the problem requires a solution in a back end space, I'll work on it there. I don't try to like think of front end versus back end as being a separate thing, because it's all in the solution space, right? Like there's no point in back-end engineering if there is no interface in some way or capacity to a user. Like what's the point? And the same thing, what's the point of a front end with no logic that does anything? So I am a solutioner. I come up with solutions. Although not very well in here. Not very good with solutions here. Solutions engineer, yeah. Just use the awful buzz term as full stack. Yeah, which full stack. Okay, here's my current definition, which has changed over the years. But my current definition of full stack is anyone who is across all parts of the application. And that means planning what the application is, designing the solution, testing, coming up with test cases for the solution, usually before you even build it. Note that that's not TDD. Well, it is part of TDD, but it's not like automated tests necessarily. It could also be figuring out what the manual tests are. And then building it, deploying it, verifying that it works, and then deciding what updates to do or not. So there's a lot of business sort of applied to that too. And what we want to do is, when we're trying to be full stack, even if you're not good at it, well, so a solutions architect is someone who is good at all of them together. But a full stack is someone who is dipping their toe in and keeping aware of all of those parts, and then being able to be part of meetings and other decisions at all levels of the application. That's what I'm thinking. And a lot of people will probably disagree and hate me for that. Full stack should deal with DevOps too. How can you deploy something without, like, DevOps? Okay. How can you deploy something without operations? And if you're a developer, you need to have some operation skills to basically do that type of thing. Otherwise, you have to reach out to an ops team. And if your DevOps team is doing all the ops, they're not a DevOps team, they're an ops team. Whoa, you really have experience? I mean, I find that it's interesting. A lot of people say that you lose a lot of opinions as you grow and becoming more senior. But what I found is that your opinions on different things change. Like, instead of opinions about languages, now I have opinions about how teams, companies, organizations should operate. Full stack doesn't mean you don't have DevOps and designers. Correct. Yeah, you still. So, yeah, full stack doesn't mean like you're one developer or like a super developer who replaces everyone else in all eternity. It really means that you can pair with all those people. You can try to take on all those things. Doesn't mean you're good at it. Doesn't mean that you're like someone else is going to be better at you than that thing. But you should never be the one who says like, nope, I refuse to even try. That's not going to fly in most companies. Have you been using RabbitMQ in your programming career? I have not used RabbitMQ. All queues that I've ever used, I've either created myself, or I guess the one queue I used was SQS, the simple queue service from AWS. A good company also has you like a level 1 as a front end, but also a level 5 as a back end. Yeah, they create something called a skills matrix, which I am a really big fan of creating skill matrices for ourselves. And if you have a good company that won't weaponize it, it's good to have them, like it's good if they have it too. But if you don't trust your company, then, or they're weaponizing metrics, then yeah, it's bad. That's all I can say about it. Okay, so math puzzly things. So what would happen if I do something like, hey, move x1 to ACC, sub x0, check if it's Check to see if P0 is greater than ACC. No, I don't even need the checks. I then just send this on over, right? Like I then like, I don't know. Sure, let's add P0 for some reason. And then move ACC text 3. If I do that, you turn on, and now for 84 coming in here, 38, 93. So you should be off. So you're on, and you're off. Now, do you ever turn in anything else? I mean, sometimes one turns off. But for the most part, it's just on still all the time. So this math doesn't make any sense, mostly because I don't know what I'm doing. And I just sort of randomly chose sub and add. I could imagine that there's an algorithm we can do that then would work with this. But I don't know what that is. Or rather, I mean, of course I don't know what it is. Like we all start not knowing what it is. I don't have, my creative inner mind is not helping me come up with ideas for like what to do with something like this. And that's the concern about the puzzle, is like I don't know how to turn this into the correct input for this thing. Which is unfortunately why we're still back at the beginning of the puzzle and not working on it. Sadly can't help, you have no clue of assembly. In this case, it's not really assembly that we're struggling with. It's more of electrical engineering stuff that we're working on. The assembly is easy. that part is easy. Knowing like what assembly to write, like what the logic to implement, that's, you know, as most things are, that's the hard part, isn't it? And part of me, I don't want to look up a solution for it. But at the same time, if I don't come up with a solution or we don't figure it out by the time we end the stream today, we'll probably move on to another game for next week. Because I don't think it's going to be that fun to sort of stare at this puzzle for like 3 weeks in a row. And also, if we get stuck this hard on this puzzle, we're gonna be stuck really hard on future puzzles because it's gonna get harder, right? Like this is fairly early on in the game. Are you drinking hydrate? Thank you. I will drink this right now. Although the tea isn't helping me come up with solutions. That would be amazing. I've been drinking all morning too. Add a lemon. I discovered that when I add lemons to like a liquid that I'm drinking, I have a very mild allergy to it. I had no idea. Like I always I get little bumps all over my mouth. It really sucks because I've heard how good it can be for us. And I've tried it, and like it makes my brain feel better, and it makes my mouth hurt. And it sucks. I have not tried a lime for that. Maybe someday. I don't even have any limes. I don't have any lemons or limes in the house right now. So I couldn't even try it if I wanted to. Okay, so we have all of the math, the basic math stuff. So we have plus, minus, multiplication, and then sort of division can go in there too. Oh, how's the course going? So the course part is mostly done. We found another lesson we need to add in, which is more advanced security stuff that we can do on Linux systems. Okay, just try this as possible without the DX300, which makes sense because it's not even recommended as the part, right? That makes sense then. It's not possible. But yeah, so we're currently working on adding a new lesson to the course, and then we're also working on adding in features and for like feature requests, bugs, and other things. Well, I don't know. Like, should we just skip the DX300 altogether? Because like I don't understand it at this point, and we just like continue on with this. Although that we're having trouble with too. Because if we go back to this one. This one? Well, wait, this one I felt we got really close. Kind of close. We split our logic up to this. Sure, we'll take a look at a solution. I'm a full stack developer, team lead at Health Scholars, educator and live streamer. Change this full stack developer to solutions engineer, as you said. Yeah, that's true. Also, I am no longer a team lead at Health Scholars. I need to change that because there's no team anymore. Let's see. Okay, so let's oh, that's my get. Yeah, I'm behind on it. Here, let me update git profile description. Okay, that's in my to-do list. I will do it sometime. All right, so if we can't solve it on our own, let's at least look into this and see if we can like understand the solution. That's really fuzzy, but at least we can read it, kind of, sort of. We have sensor coming into P0 here. We have our 2 times coming into X0 and X1. We have our real time coming into P1, and we send something going out on X3 to our DX300, and then that goes out to the alarm. Right, okay. So we first test, okay, so if equal P1. So if our time is equal to on time, move 10 out to that one. Oh, move 10 to the accelerator. Hold on, just move 10 to the accelerator. Then okay, so we're storing if we're good here. Then we test, okay, if we're equal to this. If we're equal to off time, move 0 to the accelerator, so turn it off. Test greater than P0 and 19. So if we're greater than 19, so if we're, okay, so test the sensor to see if it's greater than 19. If it is, move it to the accumulator time, move the accumulator out to X3, which was either a 10 or a 0. Otherwise, move 0 out and then sleep. I didn't have even close to the rest of this stuff. It's like the 19 is like not even yeah, it's not even close to this. Is the course on Rust on GitHub private repo? Yes, the course articles are on there, and then I also put them up onto my LMS, which is where they can be purchased from. So what I'm confused about here is what about the other times? This is okay, so test equal to that. Okay, that makes sense. We're equal to on time. We're equal to this, turn it off. But then we just test the sensor. Because the ACC doesn't reset. Okay. All right, I get it. Well, okay, I shouldn't say I get it. I think I get it. To me, this is not functional at all. To me, this is stateful. This is the wrong. This is like a very different thing. And I was thinking stateless, and that's wrong. That's the problem. I was thinking stateless, and I shouldn't be. I should be thinking stateful. So if we how do I want to do this test to like see how this works? So it'll be. Okay, so let's we're gonna test equal. So when we turn on, so if we move on to on, we're gonna set U to be on, right? So test equal P0 X0, and if you are, we're gonna move 100 to ACC. Arbitrary, just choosing 100 for that, so it'll be easy to see. And then we're gonna say when it's off time, so if t equal P0 X1, move 0 to ACC. So we are below it, so we are off right now, right? Now we can move through here. But as soon as this becomes 93, oh, forgot to sleep. There we go. Okay, so it's 93 now. We put 100 in there. And it stays in there. This is what I wasn't thinking of. I wasn't thinking of storing that when it hits here, we turn it on, or like we mark and we keep that we're on, and then only when it turns off, which it's going to reset back down to here, so now we're low again. As soon as I hit off time, we turn it off again. This is what I was thinking of. I was thinking that every single tick, we were resetting the ACC, but that's not what we were doing. And so I think the problem was, it's a lack of creativity, really, which is I'm so used to working in like, I guess like in a functional system where there's no state, or like the state is not something I can just set and go on with. That's the problem. That I was like, oh yeah, I don't have a state, but I do have a state, so I can use that. That's the problem here. Okay, so given this, now I want to try to solve this. Okay, in the meantime, I'd really like the course on how to build scalable database systems with Postgres and REST. 100% would pay for that. Like how to build the database itself with REST, or how to build like scalable applications that use Postgres and REST. I can eventually do something like that with like how to build applications that use Postgres. I'll mark it down. Although scaling is like a very tricky thing. Okay, so if I do this, at this point in time, I now have you, and you're going to be 100 or not 100. I could use another thing in here, which I have to because I'm losing PCR and all that stuff. What's the status with Axum? Been on hiatus. They've updated a few different times based upon some other libraries that have updated. The most recent update, they added back in the ability to handle quitting exiting, turning off the server, and being able to nicely handle that. And so basically disconnect all the database connections and do all that fun stuff. So that's something nice that they added back in that they didn't have recently, although they had a while ago. Graceful shutdown. That's the word. Those are the words. Yes. So it's things that I was thinking of. It's just like things that like they're on their way. They're on their way to 1.0, but it still feels like a few more updates before they're gonna get there. And it does feel like a lot of these features, like graceful shutdown, they were waiting for other libraries that they rely on to update themselves. All right, one more ad starts in 5 more minutes. So I'll try to remember right when it begins. Okay, so at this point in time, we now know if we're on or we're off. Let's, since we looked at the solution with this and it's not recommended, let's try not using this. We'll use something like this out. So now if we have our sensor coming out in here, and we have this here, we can, at the end of U, just move ACC to X3. And so this will come in so as 100 or not. So if you're equal, so test equal to 100 x1. So if you're equal to x1, then I want to take the sensor in. So then let's do test greater than P0, 20. If 20 is greater than that, then I want to move move 100 to P1. And I might want to do something like this. Move 100 to ACC, otherwise move 0 to ACC, move ACC to P1. Sleep 1. I wonder if this does it? Yeah. Okay, well, first page it's doing. So close. It's the 19. It's the 19. Do you think you can make a course on the topic above? It involves things like high availability, disaster recovery, load balancing, and similar. We got it. Okay, thank you, Stacking, for all the help with that. The okay, so let's do a quick retro. Okay, first fit, and then we'll retro. Do I think I can create a course on this? Probably not a course, but what I could do is create a series of like micro courses on each of those different things, right? And specifically, it wouldn't be like a course on high availability. It would be a course on the tools that are used to ensure high availability. So maybe like a tool on how to do red-green deployments, a tool to on how to like recover from like, you know, how like because each tool to do you need to learn, and then it's going to be scenario based of like which tools do you use in each scenario, because that's the problem here. When it comes to scaling, there are many tools that you can use, and if you choose the wrong tools, you counter the scale. Like that doesn't make any sense. You basically move backwards. You slow things down. You make it worse. Basically, I need to make a course on theory of constraints, which is a philosophical idea. It's way more philosophical than technical. Here's the general idea, and it's easy to state these things, but it's not necessarily easy to put them into practice, because this is going to be there's a cultural part to this too. Generally speaking, you want to find where the bottleneck is, and there's always a bottleneck. Don't find any bottleneck. Find the bottleneck, the thing that's causing it to be slow the most. Ignore everything else. Find out, then you have to discover, why is that one part slow? Now, it could be your database is misconfigured. It could be something like your database your queries to your database are slow, or you don't have the right indexes or the right kinds of indexes set up. Maybe you could do something with material views. Maybe it has nothing to do with your database at all, and it has to do with the CPU. Oh, an ad break just started. It's a lot of stuff. All right, well, ad break just started. I wanted to go over retro stuff without the ad break stuff. So I will take a quick break, refill my drink, and be right back. Also, I got messaged. And somebody just messaged me asking me about concurrency type stuff. So that's fun. Okay, so which is like related. I will be right back. I need to go use the restroom and refill my drink, or maybe grab a snack. All right, I'm back. Okay, so I don't know if you got ads, so I left to get myself a snack. Got a part of an orange. Okay, so if you really need a drop-in solution, I would look at CockroachDB and a creator used to stream on Twitch. Oh yeah, I remember that. I don't need a solution, I need knowledge. Okay, yeah, so theory of constraints. You want to find what the block point, like where the what was the word I was just using? I just forgot what it was. You want to find the thing where it like funnels in and it gets really slow. Bottleneck. Yes, thank you for that. Words in my brain right now. You want to find the bottleneck, the biggest bottleneck. All other bottlenecks might actually not be bottlenecks because they might be caused by problems caused by this bottleneck. So you don't want to solve anything else. And the puzzle did really destroy my brain. It did. So we get with the bottleneck, then perform an experiment to try to solve that one bottleneck. And then implement that experiment and then see if the bottleneck goes away. So let's imagine that you go to the home page and it's really, really slow, or it crashes crashes. You think that it's because maybe like 200 or so people are going on, but you need metrics, you need data to really be able to determine. You can't just say like, oh, my homepage gets really slow when a lot of people are using it. It's like, okay, well, that's not enough data. We need to look at like, okay, the database is taking this much time when that's happening. This much RAM is being used, this much everything. You need all the data everywhere. And you can say, this is the slow part. Now you isolate that one part and we can say, okay, what's one thing I can do to make that faster? And then you implement that. And then you have to wait and see, do the metrics change? If they didn't change, your solution didn't do anything in either way, better or worse. Undo the change and try another experiment. And eventually, oh, you're going to do it. It's going to be hopefully faster. Great. But then it might actually not solve the problem. We're still crashing. We're still really slow. Well, what's happening is you've now fixed that bottleneck and uncovered another bottleneck. Now you attack that bottleneck. And that's the only thing you can really do. And so maybe the solution is to use a queue, but maybe the solution is not to use a queue. Or maybe what kind of queue do you want to make to use? Because there's multiple types of queues. Which one will be better than the other? That's quite a deep dive into software you're building. I thought there are developer standards that prevent such things. If you want to over-engineer it, you can cover all possible cases, but that's really, really expensive. Like, what if the problem isn't that you have a lot of users? What if the problem is that you have a lot of data per user? And you have at most 10 users at a time, but they each generate hundreds of megabytes of data. That's going to be a different solution. That's not a database problem usually. That's something else. Also, don't forget about data queries. Most people overlook them, and most of the time, a bad query is also over thrashing your database. Yeah, I mean, oftentimes it'll be database things, but it could also be. So at one point in time in the past, we thought it was database queries. We thought it was other things, but we used this method. And we put in we set up New Relic, and we looked at all the data, and it was actually it was none of those things. The problem was that the code was set up by someone previously that hit Salesforce API a couple hundred times per second, right up into the edge of what we were allowed to hit. And Salesforce API has 4 or 5 nines of uptime, that they guaranteed in their TLAs, their SLAs. And it turns out that 5 nines means that out of 100 or so requests, one of them is going to fail. That would be more like 1,000 requests. So every once in a while, one of them would fail. And then they had set up, they were trying to fix the problem. They had set up, the nines. That's how many nines are after the decimal. So if somebody says we're up guaranteed 99.99999 percent of the time, that's the 5 nines, right? So that's 5 nines after the dot in 99 dot. And SLA for service level agreement. So they promise that they'll be up X amount of percent of time, but that doesn't mean that means for 1 hour, they're always going to have errors. It means that 99.9999999% of the time when you send a request, it's going to work. But sometimes it might just fail. And we were sending them enough requests that we were hitting that, the 6th nine, which means it was failing. But when it failed, we didn't handle it properly. It got sent into a queue to retry, but it didn't just retry. It retried. It would retry all hundreds of the different requests again. And so if you got a couple failures, then we would exponentially grow the number of requests that we sent to them, almost guaranteeing that another failure would happen within that, which then you can imagine pretty bad. Nothing to do with anything that we thought it was. It was just bad. Like we didn't properly cache, properly set, like minimize the number of requests that we were doing to Salesforce. And that was the problem. That was the real thing that we needed to fix. So it's really just investigation into like what's going on. Okay, so let's do a quick retro for this. Why did I not be able to get this right away? This is our first one. So I tried to solve this with like a minimal number of these things. What happened? Well, as we can see, it didn't occur to me that the ACC sort of like sits around, although it should have, but it didn't. If I were to craft a question to myself to ask in the past that would like trip myself into knowing, oh yeah, I think we had a bug. I must have somehow tripped a bug. Anyways, back to the retro. If I were to create a question for myself to help out, it would be, what is a way to can we track the time with all, like, you know, can we track the time? I don't know how to like ask myself a question in the past with this. Maybe just a reminder, hey, like your ACC, there's a trick with your ACC and time. I'm not going to forget that in the future though, or at least I hope I don't. Because then, yeah, that makes it so much simpler. So now we come to this one. Nope, not that one. Not that one. This one. We can see, and the thing that you sent me, this part, I wasn't even paying attention to. The thing that was like, oh, I totally forgot, and now this like unlocks me and unblocks me, was the, oh yeah, I just test to see if I'm equal to this, and that. And I remember, Stacking, you did suggest I only need equal, and I'm like, nah, that doesn't work. Because I was stuck in the loop and of the assumption that I didn't have state every time. Every single tick I had to recalculate based upon the time if we're legal or not. But that's not, I just need to use state. That's the thing, is like, I do know that ACC is a register that doesn't need to get, that will not get reset unless I reset. Like, I know that, but I wasn't thinking of it, which I think is the problem. Because I wasn't thinking of it, I didn't, like I automatically just threw it out. because it was it wasn't an assumption. It was that knowledge. It's knowledge that's false. There's a great quote in the first Men in Black movie, where was it K and J? K tells Will Smith before he becomes Jay, yesterday you knew that there were no aliens. Today, you know that there are. I think that's what's going on here, is that it wasn't even just like an assumption. It was just this is the worldview, this is what I know. And because it's set in stone, my brain looks for the things where I'm not confident in, and we test those things. But not the things that I'm confident in, even if they're wrong. And that's where like, especially when puzzle games like these, we have to be good at, are we making any assumptions that we don't think are assumptions? That's what I'm gonna have to struggle with. That's the struggle, really. So thank you, Stacking, for helping out with that one. I'm glad we got past it. And we'll see how we, hopefully we won't get stuck like that again. Okay, so we got this. Let's see. Objective complete. Just letting you know that your design for the infrared sensor component was well received by our partner and is set to be integrated into a number of products currently under development by various defense and security firms. Obviously, our performance here opens the door to more jobs of this nature, so thank you for contributing to Longten's future. Hang on, we're becoming a defense supplier? I mean, again, this infrared sensor is a terrible sensor for all the things that he said that it's going to be used for. So, good luck. Okay. Woo says, note that I'll be working remotely today and maybe tomorrow, just in case you're looking for me in the office. That's weird. I thought you got back from your trip yesterday. I did. I've been stuck in a traffic jam on the way back from the airport since then. You've been in the same traffic jam for over 24 hours? When a city grows as fast as Shenzhen has, it's natural to expect there might be some strain. I'm fine. I have food and water in here. Maybe next time a virtual meeting is better. Carl is that guy, right? Yeah. Also, that is, I remember hearing about some disastrous parking lot, traffic. Has there ever been one that's over 24 hours? All right, next puzzle. Virtual reality buzzer. All right, so David is giving us something. Hi all, apologies for the personal side here, but I've met this wonderful girl named Zhao Mei. And well, to make a long story short, she's set to move in with me next month. There's just one small issue, and it's something I thought maybe we could create a product to help with. See, when I'm doing my VR sessions, it's easy for someone to sneak up on me because I can't see or hear them. Awkward, to say the least. This inspired me to think up a product, a simple vibrating buzzer that attaches to a VR headset so it can be felt even during the most intense sequences. Connecting that to a radio controller, I could place the button outside of my study, and Zhao Mei could buzz me when she needs me, with no chance of me being caught by surprise. What do you think? I'm sure plenty of other VR enthusiasts might find themselves in a similar predicament, and this is a solution inexpensive enough to be an impulse buy. I have to be that, like, The product engineer in me immediately just says, okay, can you just set your phone to buzz? No, be Carl. Okay, congrats, David. Note about the radio chip you'll be using. Yes, literally nobody in the company questions this at all. It's just like, okay, whatever. We're just gonna make this and hope that there's a market for it. We're not gonna do any market research. We're just gonna like assume that because an employee wants it, we're just gonna build a bunch, like one for them. Sure, whatever. As long as they pay me, right? Note about the radio chip you will be using. Normally, reading X bus causes the microcontroller to block until data becomes available. However, this radio has a non-blocking X bus buffer. The non-blocking buffer will immediately return a value of -999 when no data is currently available. Should make it easier. Oh, okay. Okay, so here's our Wi-Fi. Radio RX is a non-blocking X-bus input connected to a radio receiver. Buzzer is a simple output connected to an electromechanical buzzer. That. When a data packet is received over the radio, read it and execute the corresponding command in the following table. When the power is on, turn on the buzzer. Okay, can I see what this looks like? Yeah, so it's gonna be just... Oh, weird. Okay, hold on. It's like 1 and then it never goes back to -999. Is that just a bug in here, or is that... Okay, this is for transactions, so I will never read out of there. So this is unnecessary. I'm not sending out. Okay, -1, then we go to 1. Okay, then it is -99. So it was just a visual glitch. Okay, got it. So this seems, you want me to send probably 100? Yeah, expected 100 power. So I don't need that. We could just go with this. We want to test to see if you are 1, we send out 0. No, if you're 1, was it? It was 1. If you send out, oh yeah, we could actually see here. If you're 1, we send out 100 here. Otherwise, we send out 0. So if we just say test equal x0 and 1, then move. Look at this. I'm getting these part not recommended again. Huh. I wonder if that's a bug in the game. Move 100 to P1. Otherwise, move 0 to P1. And I bet we can use, I bet this is where this will be interesting, because if let's see, -99 ignores the signs, yeah, all of them would go out and be on. That's not right. I don't want that. So no, this would not be useful. Why did that not work? That first one worked. Test equal. You're not 1. Oh, I'm just supposed to do... Oh, okay, so it's the same problem. Yeah, okay. So I was misunderstanding how the signal works. This is 1 and then it goes back to that. I'm either sending... Okay. So I'm receiving a 0. So here, let's negative 99, 1, then back to negative 99, but I should be on, off, on, off, on, off. Like the buzzer is not just on all the time. I want it to, that's how it buzzes. And then here we're gonna get 0. Okay, got it. So we want the same thing, like normal, right? It's the same exact idea as last time that we got stuck on. So if we test equal x0 and 1, we're going to set ACC to, let's just set it to 100 to mark that it's like on now. We move 100 to ACC. If we're equal, if x0 is equal to 0, we want to move 0 to ACC. So we're off now. Now we can eventually like begin the actual thing, right? Based upon if this is on or off. If we're on, I want to now do this, just like send out 100 out. And then like pulse. So on like every other one. So I could, let's see. I could use one of these things to like actually store data and go back and forth. But then we also saw, and then I kind of want to, that doesn't, oh, I was really hoping this would like bring all these in. It's hard to see what these are. It was this thing, right? I'm kind of curious. If I send, so if I move, let's say ACC to P1. Let's just move that out. I want to see, like, this will send it, false. Oh, you're unable to access LinkedIn? An error has occurred. I'm not able to either. That's fun. Yes, I'm sending 0 out and that becomes a 100. So this reverses it. 0 to 100 and then 100 to 0. So this is a NOT gate. Or it's an if and it reverses. So if it's 100, it becomes 0. If it's 0, it becomes 100. So then, was there, I thought there was like a multiple one of these. That's not the right symbol. I don't think I'll be able to do that easily through here. I don't think I can easily do the other one, like this thing. This doesn't make any sense to me here because I'm already have the 100 or 0, essentially, based upon this. Now, could I go in straight from this? No, because negative 999, 1 and 0, I would actually, the negative 991, there would be no difference. It would be actually sending all of them out. So like that doesn't make any sense, at least directly from here. So instead, what I want to do is, let's take you put you in here. And we just want to store based upon like what data is, so we can have our pulse then. We now send a let's see, do we want to send a pulse out? So move accelerator to P1. Oh, I know. Hold on. I do want to do the original thing. I just do another one of these. Aw. Oh, they don't line up. Say P1, P0, okay. We do that. Okay, so this sends out the 100 or the 0, right? So like then we're gonna move P0 to ACC, sleep, 1. But that's always let's see. Move 100 ACC, move ACC, move 0 to ACC. If you're equal to 0. Huh. Why did that not work? Why are you always 100 now? Because you got set to, now I'm confused. If you're equal to 0, move 0 to ACC. If you're equal to 1, set that to ACC. But you shouldn't be, okay, so you're 0, you become 100, we move out. Wait a second. Why are you skipping? This is x0 equal to 0. Why is that skipping the move 0 to ACC? Test equal to 0, which, oh, because it's negative 999. This becomes 0. Okay, so everything, okay, so everything is gonna be fine. Now you're gonna be 0, so I want hit there, Was that not 0? Why? Okay. Back to the drawing board here. I want to move x0 to ACC. Sleep 1. I want to... Okay, negative 9 and 9. Okay, no, 1. Then negative 9 and 9. 0. So, test equal to 0. No, test equal. x0, 1. Okay, it becomes 100. Now you should stay 100 until we hit this. Am I using test equal to wrong? Shouldn't test equal to 0 equals this work? Because that was a 0, right? That's the value coming out here. And we saw that that's what was being put in. Huh. Now I'm really confused. Profiler is not helpful. Yeah, I don't think I can. So this is test equal to ACC 0. Okay, what if I throw this into ACC first? Okay, if I'm going to move that into ACC, this won't work anymore. I need an actual state. Okay, so just make sure I'm not fully insane. That becomes a 1. That becomes a 0. Okay. Move. Okay, so then we want to test equal to 0. So we're going to say test equal to ACC and 0. So if actually, let's test if you're 1. So if you're 1, we want to move 100 to DAT. We're going to test equal ACC 0. Move 0. That. And then we're going to move that P1. And so then you go into the ACC and we sleep. So 0, 0, 0. We have 100. I feel like that was one turn late. Yeah, you're still 100. And the next one, it goes into this. Do I need to start by sending what we have in data out? Oh, because you never became 100. Okay, so that's not right. I want that at the end. I'm just confused why, like, it's not. I feel like we're off by 1 on the ending. But maybe everything will be fine. Okay, so if we move you to the accelerator. I feel like I want this to be a bigger one too, so I can have the state on it. Because I want to turn this on and off, on and off. Oh, I don't have to chest it with this. We just use this as a state. So we start with move 100 to ACC. Test equal P0. If you're 100, then I want to let's say I want to move ACC to P1, but then I need to like set ACC to be 0. So test equal ACC 100. If that's equal, we're gonna move 0 to ACC. Otherwise, move 100 to ACC. I then want to sleep 1, jump to start. And so we're just using that as an initializer. I probably do it the opposite if I want to be a little bit more efficient. We just say, okay, if you're equal to 100, then we you just took a bathroom break, so you're let out of the loop, but it couldn't the send chip just pulse, which always high? I guess we could. Can I pulse? So can I just do this? Let's see. So I can't just move that to 1. We have to. Okay, so we have to. Okay, so how do I know? How do I know what if I'm on or off? I wonder if I could do something silly, like move 100. So that's equal that 100. Move 100. P1 moves move 0 P1. Wait, you don't want one? Yeah, expected 100 out. Wait, why didn't that go out? Why did that mark that I didn't send 100 out when I did? Oh, wait, because I just moved. Oh, hold on, I have to do this. That's why it undid. I think that's what I have to do. There we go. Okay. I mean, a little bit kludgy, but we made it cheap. Also, who in their right mind would attach this to the front of your head, which is already super heavy from the VR? Like, the entire point, like, everybody's trying to make it lighter because it's like giving people headaches and making it worse. This should go on the back of your head. All right, so cool. We got that done. 2 puzzles done today. You did that a little different. Add 2 chips where the second one was just looping and sending the pulse until told to stop. Interesting. Okay. I was thinking about doing that, but then we just like, oh, we'll just send it there. And then it just works. Okay, wonderful. This is exactly as I had imagined it. Okay, great. Thank you. Prototyping new ideas. Sometimes a decent product idea falls out when you're faffing about with chips and code and the like. So I've set up an empty prototype board for us to experiment on. On you go then. Chips. Okay. We can test with some different parts too, such as custom LCD panels. I'll add new other parts as we receive them. Custom LCDs, are you serious? That's brilliant. We can make retro style handheld games. Let's all take turns designing one. Carl, come see me. If you have finished all your other assignments, I have more work for you. Who's this Carl fellow you mentioned? Nobody we know. Okay. Design and create an electronic game. All right, well now I can use everything. He is. Okay. Oh, we have a lot of things here. We have oh, we need like save like actual PNGs for this. Oh, that's too bad. Is it the same for this? No? Oh, can I actually do wires? Oh, this is cool. Lots of fun stuff to play around with, but I don't have a game idea that I want to make. Like what game would we want to make? The how to press a button as fast and like track it? Can we do that? Also, there would be no way for us to simulate it, right? Like we couldn't play the game. Are you a button? Oh, I can play it like that. Oh, okay. So simulate actually is then playing it. So I can turn the time all the way down. I'm actually really curious. Okay. What's this gen? I saw that the gen. So gen 1. Oh, it's a register. Gen 01. Oh, that's not found. Didn't one of the solutions that you showed me had like a gen? Okay. I don't think I can create a random number, can I? Like there's an input result. Is that just a switch? Yeah, that's just a switch. What's that? That's a screw. That's a screw turning? Okay. Is that it? Oh, that's an LED, right? Wait, okay, outgoing music. That's interesting. Wasn't there a clock? Oh, was that that? Oh, that was the timer. You're right. That was the timer. I can't. Wait, can I not set this? Oh, that kind of sucks. Was there one where it like gave me the actual time? I don't see that one. This is a buzzer, right? I like feel like I'm not getting all the things that I really want to get to like make the game I want to make. I can only turn a screw while we're simulating. Like that. But as soon as we're done, it resets to 0. That's useless. Cause like we had the time. Yeah, this was like the DT2415, which is not present here. Okay, here's the idea that I was gonna have. I wanted to turn on a light or something. Like we can have this light out here. And we can just basically say, okay, turn this on. So like move, I don't know, 100 P1. Turn this on when like the timer counted down or something like that. But I don't have a time, like I don't have a time, so I can't like keep track of ticks. I guess we can sleep one and then go until this thing hits. That might work. And then we press a button. And then if you press your score is basically you're just keeping track of how long it took you to press the button. Like that's really it. But here, we'll do it without you. We'll just say I need another P. Let's come out of this one, so you go there. Oh, you're X. Oh, nice. Okay, so let's just we'll just start by adding 1 to the accumulator. If we test greater than a completely random number, I guess that could be this thing. Test greater than x0. A completely random number. So let's say like, I don't know, 10. No, ACC. Okay, so if ACC is greater than this, I think it's the other way around, right? If ACC is greater than x0, then we want to turn on the light. So 100 to P1. And then we want to press the button. So now we're listening for the button click. And so I want to check if test equal 100 P0. I think it's like 100 P0. That would make sense to me. If that's equal, then move that to X3. Oh, ad break just started. Sorry about that, everybody, but we're making a game. We can't stop for games. Move that to X3, and then, okay, so at the very end, we're going to okay, so if greater than that, we're also going to move add that doesn't make sense. I'm just going to sub 100 move move ACC. Oh, I know. Sub 100, move ACC to that. Move that to X3. If the button is not pressed, jump to start. And then if we get to this point, I won't like sleep one at the beginning. Or do I want to? I probably want to wait. So I do all this stuff and then we have to wait. Jump to start. Okay, so we move 100 to P1. Okay, so we turn that on. I guess I almost feel like I want sleep one there if we're jumping. Sleep one, jump back to end. Test equal with 100 P0. Okay. Oh, that never turned off. So that just doesn't work. This thing just doesn't do its thing. I'm like, oh, I'm sleeping 10? Why am I sleeping 10? I can't catch up. I can't like set it. Okay, hold on. Give myself some time. Ah! Negative 72. I don't think it took me negative 72 ticks to press the button. Oh, it was 72. Oh, yeah, that's what it was. I have to subtract really what this is. That's what it is. So I just don't sub. This is stupid. Well, just like from how long it takes me to press the button. So don't need to sleep. Let's see, it's add one. We test greater than accumulator x0, so I don't need to do that. We're 100 P1. Yeah, so just immediately turn on the light. Test equal. Okay, so if I press the button, then if I have pressed the button, then jump to end. Is that right? Yeah, jump to end. Otherwise, I don't have to have this anymore. Sleep one, jump to start. No subbing. No need to do this. And start. I don't need to do that. We just move ACC to X3. We sleep one and jump back to end again. So now, that seems wrong. 100 P1. There. 9 ticks. It took me 9 ticks to press the button. That's our game. This is the best game in the world. Everyone loves it. I can make it really hard mode by turning on speed. 22 milliseconds. I assume that's like going to be, no, it's not even milliseconds. It's going to be ticks or whatever tick time this is, which is going to be like, I don't know, theoretically nanoseconds or something like that. So anyways, yay, we made a game. There's no way for us to verify. Click and hold this button to indicate you have completed the objectives. There's no way for us to verify this, so we're trusting you. Keep holding. You promise you really made a game? Okay, we believe you. Great work. Yeah, I made a game. It's fun. It's good. Fine work there. Well, I suppose it's my turn now. What should I make a game about? Electrical engineering? Ha ha, that would be a terrible game. Meta. Shenzhen days. Things visitors say. Okay, so Tilly's back. Today I want to talk about the goofy things visitors here tend to say. Actually, just one thing. It feels like every time a certain kind of Western visitor comes to China and looks around, they go, wait a second, I thought China was communist, so why is everybody shopping at the store? What is up with that? And that's when everyone around laughs because, one, the dude always thinks he's making some good observation when we've heard that at least 1 trillion times before. Trust me on this. And 2, gosh, it's complicated, okay? I know, cell phone, right? What's important is that so many of these guys' impressions of communist China still come right out of the 1970s, and they're so surprised when they get here. Like they had no idea that things were changing dramatically here this whole time. Well, hey, you haven't been sitting around doing nothing since Nixon, and neither have we. And we built more than just the factories where all your smartphones and game consoles come from. The world is changing, fellas. Empty your mind. Don't cling to your fixed ideas. I believe in you, okay? Okay? I mean, she didn't say, like, what was going on. She just said it's not that. All right. Okay. From Carl. Carl wants some help. I'm wrapping up a project to make a game console and could use some assistance. Before you get too excited, it sounds far more fun than it actually is. The console is just a tiny super cheap box we're making for Sleep Cubes, the big Japanese capsule hotel chain to stick in every pod. The games will just be some free dross they find, I'm sure. At any rate, I've got it mostly done. I just need a module for the little wireless controller that comes with it. I'll ping you, you tell me what's going on, nothing more than that. Can we make a program just to move Carl's email into the trash folder? I mean, no, they don't let us play with our desktops. Okay, X and Y are simple inputs connected to a joystick. A and B are simple inputs connected to buttons. Radio RX is a non-blocking X-bus input connected to a radio receiver. Radio text is an X-bus output connected to a radio transmitter. When a data packet is received over the radio from the game console, respond with the following 3-value data packet, making sure to use the most recent input values. So we have X and Y, 0 if A equals 0 and B equals 0, 1 if A equals 100 and B equals 0, oh wait, okay, respond to the 3-value data packet. How do I send a data packet out? Okay, so now we needed, and now we're back to this thing again. What part type is this? This thing. Wait, am I receiving anything at all with this? When a data packet is received over the radio from the game console, respond with the following 3-value data packet. I'm just curious, like when they say data packet, do they just mean it's going to come in? Oh yeah, so each tick, it's going to be another value. So it's going to be on the no, we're just going to get -1. On RX, we're going to get -1. Okay, so whenever we receive -1, we want to send out, oh, just thing, tick, tick, tick. So X, Y, and then whether or not the A, B is being sent. That's what it is. Okay. Okay, so I can't use this thing because -1 and 999 will both trip this. So that's not helpful. I need some logic between it. So I can't just go straight from this to like this thing. They're both negative, so I can't do something that like does something with negative numbers. If we grab you out, I then want to grab the X and Y, just go straight out, right? Like we just send that. So we just want to keep these. So I imagine that we want to say something like this. Actually, just give myself room. Let's do this. Oh, I can't. So as soon as I hit the -1, we send out those 3 things after 3 ticks, and that's it. That's all it really is. Okay. Sending out the X and Y exactly as they are, I think. Yeah, so you're 63 and you're 37. Okay, so yeah, whatever you are at this tick. Oh, we need to keep it. We need to store it. So if I test equal to x0 -1. So if you hit that, I now need to get access to these at this exact moment, whatever this is. Oh, nope. I keep on meaning to press tab, and I'm like, I moved my keyboard forward, and so now I hit the wrong thing. Hit caps lock instead. So if I take the X, oh, we can just send this out right away, right? So we can just say move P0 to X3. But then I need to store the Y, which is a P. Now I can't. This seems like such a terrible idea. There's no way that I know which order I'm going to get these in, do I? Like, I can't just say, like, hey, move P0 to ACC, or, like, to data, and then we're gonna sleep 1. Move that to x3. Sleep 1. Move like, I don't know. Let's just say 1. We'll just say 100 to x3. Sleep 1. And then we start over again. That doesn't seem like it's gonna work. I got none. Yeah, okay, so this is a terrible idea. Okay, so move P0 to X3, so I just send that out. Oh, 63, so it did send out 63. Okay, so I got that. And then... Ooh, I get the 63 again. Okay, so yeah, I'm only getting this one and not the other one. So I can't just do silly things. I mean, they let me do silly things. It's just not a good idea. So I wonder if I can create something like this. Shortest path wins. Okay, that does make sense. We have 2 P0s coming in here. So if I do something like that, now I can send out... U. So this will be... Okay, so move P0 to X to X0. Move P1. It wasn't P0, it was P... Oh, this thing. I want to do... Oh, I'm gonna have to drop the inputs. Oh, okay, so you're gonna be something simple. You're just gonna move P0 to X0. Move. Do I want to sleep in between these? I think I have to. So then I sleep 1, move P1 to X0, sleep 1. So this will just be every tick, every other tick doing one than the other. So like XY, XY, XY. You are okay, as soon as you're -1, I want to move X1 to X0. Sleep 1, move X1 to X0. So just repeat twice. Sleep 1. Now, otherwise, if you're not equal to 0, I want to, I need to, I wonder, does the sleep ignore it or does it require moving? Yeah, okay, so it needs to be red. So I need to basically move move x1 to null. Is there a null? Where are the registers that I could send it to? Oh, not. That would have made things easier. Sleep until data is available to be read on the Xbus pin specified by the operand. I like this more. SLX. So if I SLX on, so I have another X here. What if I do this? Oh, wait. What if it's even better? What if I do XLX X0? And when that happens, I want to move. Can I do it all in one tick, or do I have to sleep? I think I have to sleep. Sleep 1, move P0 to X0, move P1 to ACC, sleep 1, move ACC to X0, and then we go back to sleep again. And so here, if we get to this, I want to start by move 1 to X1. And then I probably have to sleep to let it do its thing. And then that sends out. Heart not sleeping blocked on raid. Equal TX -1? Wait. What's not? Is that not how to do it? P. Port? No, by the pin. Okay. Yeah, so wait until X0. Okay, so what if I do this? SLX X1. Move 1. Oh, because I never said okay, hold on. Move 1 to X0. Yes, this is X0. Oh, this is transaction. Wait, what did I do to myself? Okay, so read X3. If you're -1, move 1 to X1, and then come back. Okay, we got to here. Move X1 to null. Right, because there's no null. But now I don't have to do this anymore. I think I have to sleep 1 here. I think I have to sleep 1 here. Move 1 to X1. Yeah, okay, so we deadlocked on ourselves. So I have to... Oh, that's why I had the sleep one there. I wonder if I want to. Yes, that's not going to work. So we have to do this here, where we say move 1 to x2 and sleep on x1. Oh, deadlock. Move 1 to x2. So that works. Move p0 to x0. You need to sleep. Okay, so if you're equal to -1, move 1 to x1. Do I want to? I don't want to sleep then, right? Move x1, x0, then I sleep. Okay, we got a little bit farther. Part not sleeping, blocked on right. Move 1 to x2. So does that need to sleep? Figured that would sleep. Yeah, part not sleeping, blocked on right. Move. Oh, do I need to do something with the data? I need to do something with the data. I need to move it to like nil or nothing. Null. There is a null. I want to move x1 to null. Okay. So we're successfully sending out the x's. And then I'm not sending anything. Okay, I'm not sending the y out. So I want the y to go out too. However, I'm using 2 wires for this. There's no point, except, oh, because this can be the same thing out. Okay, never mind. This might work. This might work. Let's see. So move x1 out, move x1 in here, sleep 1, and so this is move that to null, move this to there, move this to there, sleep 1, move this to there, sleep 1. Oh, why doesn't that work? Yeah, I'm not getting a second output. Okay, so I just sent out 63. I sleep 1. Oh, and I just reset. Do I not want to sleep multiple times? Maybe the transaction doesn't work that way. Maybe I could just do that. No, I can't do that. It's blocking the read, so I have to sleep. But it's not getting expected. Wait a second. Expected none. Actual 37? Wait, did I actually send out 37 and I'm not supposed to send anything out at all? Oh, okay. How am I supposed to send out the data? That apparently this is not correct. Packet. XBus values are discrete data packets from -999 to 999 inclusive Express pins are marked with a yellow dot. Express is commonly used to transmit data between two microcontrollers or microcontroller and complex unit. Yeah. Yeah, we go back to the objective page. The objective page showed... Oh, is it this? Wait. This object? No, that's not object. This page, right? It just says 3 data packet. It doesn't say what a packet is, but this is showing there's no sleeps here. There's no sleeps. So I need to not sleep until the end here. You do have to sleep, right? No. X1, okay, so X1, so we're stuck in here. So X1 to X0, so like send it again. You're sleeping to wait on things, and I don't necessarily want to do that. Correct. Okay, so now I'm sending 37 out correctly, and so now it's the AB. Now it's the AB. So this says 0 if A equals 0 and B equals 0. 1 if A equals 100 and B equals 0. If A equals 0 and B equals 100, 2. 3 if A equals 100 and B equals 100. So now we're working with 100s and zeros. So I feel like this might be the part here. And either, okay, so now I could do something like this. If I do this, this would be what? Zeros, tens, 100s. That comes out here. Oh, any one of these. Oh, but I don't have any X's left over, which kind of sucks. But I could do the other way too. Ooh, we could do the other way. Okay, so let's say I just split these and send them out both their, I'm just like I'm transferring them from P's to X's. So we're gonna move P0 to X0, move P1 to X1. You come in here and now there's a point where these are both on and we get 100. Because they're both 100. Oh, I had it flipped right the first time? Oh, do I want it to the other way around? Hold on, we can do this. We can do this. Okay, hold on. Reset. I really wish it would give me the values that it was reading out of here. So I could just like visually inspect this. That would be really nice. But I'm not gonna get that, so we're gonna take, might as well take this. Let's move. Oh, I think I actually only get one of these. I only need one of these. It'll be fine. This will be fine. Everything will be okay. Nobody needs to panic. Okay, so let's move X2, ACC, and sleep. Let's just see what we got here. So we're on 111. Okay, so yeah, we got, if it's 1, you're on, and if it's 11, you're on. Okay. So let's move X2 to ACC. And then, okay, so 0 if A equals 1 is 0 and B equals 0. So I'm gonna get 0 regardless, right? I'm only gonna get it if it's on. So if A is 100 and B equals 0. So maybe we'll just start ourselves with 0. So we just move 0 to that. If A equals 0, okay, so A is this one, which is going to be the ones place. So it's going to store it in the ACC register. which means I lose it. So I can't move 0 to dat. I can't like just say, hey, move 0 to dat. Instead, what we're gonna do is we're gonna have to move x2 to ACC, move ACC to dat to keep backup of it. We want to DGT 1. So give me 1. So if it's A goes up first with B off, which means that that's going to be on. Actually, wait a second. I don't have to do this. This is silly. I know what this is. Okay, so hold on. If this is we have 3 choices. 0, because nothing is being pressed. 1, because only A is being pressed. 10, if only B is being pressed. And 11, if both are being pressed. And we can just handle those. And so okay, so test equal, I guess we'll just move into ACC and then we can just use it. Actually, does it matter? I can do multiple tests on this at the same time, right? Test equal x2 and okay, so if you're both 0, then I want to move. Oh, we're gonna set move 0 to dat. Test equal x2. So if A is 100, okay, so if A is on, which is that one, and B is off, so if that's equal to 1, move 1 to dat. Okay, test equal x2 to 10, move 2 to dat. Test equal x2 is 11, move 3 to dat. 3 to dat, and then at the very end of here, we're gonna move dat x0 and then sleep. Problem. No, not problem. We're gonna move it to P1. So before we sleep, we're also gonna move out whatever this is. No, we're also gonna then move out your P1 to x0. All right, it seems to be working. I feel like I'm redeeming myself with this one, like getting this one that you didn't get stacking because I got it. And we spent like a day, like a full day, maybe more than a full day working on the other puzzle. But it works. Yes. All right. Thanks, mate. I owe you one. You just helped me make thousands of dead tired salarymen marginally happier. That is, if they actually find the console and use it to play a game before passing out. Yeah, the DX really tripped me up going the other way like that. Okay, yeah. I think the flipping of it actually helps like sort of understand that. Definitely. Okay, we'll read this last thing and then I think I'm gonna end because I am tired. It's after 3 now. We've been streaming for close to 6 hours. And this is a hard game. It's fun. It's good though. Feel the connection and get ahead from your virtual friend. Are you lonely? Do you feel isolated and disconnected from the world? Scientists have shown that a lack of real-life ties to others can lead to depression, which in turn can negatively affect performance at work. Don't let the lack of human interaction reduce your effectiveness. Virtual friends from BuddyBots are quality friends nearly indistinguishable from real-life people. Our characters are developed by the world's top personality designers and are completely customizable, so whether you want a supportive presence to help you through a difficult time, or a flirtatious sidekick to banter with throughout the day, you're covered. Subscriptions are flexible and competitively priced with other bot companion services. Stop being lonely. Feel the connection and become a top contributor to your company's success. You know what's really sad? We're almost there. Like, I expect to see this marketing email in my inbox in like the next year or 2. And that's really sad. All right. As I mentioned, I am feeling really tired, but I am really happy we got through the infrared sensor. That was a tough one, but we got it working. And then we got 2 more puzzles done too, which I feel good about. Thank you again, Stacking, for helping out. If we hadn't gone through that one, I probably would have just abandoned the game. Maybe stepped away from the game and we've done something else. But hey, we're moving forward. So that means next week on Wednesday, we're going to continue with Shenzhen. And we're going to see, hopefully, we can move forward. And it is funny how which like parts of the game we get stuck on, isn't it? Anyways, again, thank you all for hanging out with me today. I will be back on Monday. We're going to be working on the Docker security lesson that we started yesterday, and we're going to see if we can finish that one up, and maybe we'll even get to recording it on Monday too. We'll see. But anyways, have a great rest of your week. Have a great rest of your day. And I hope you have a good one, and see you next time. Bye.